Now I'm on to a negative 2 days from a 13 days planned. So eventually I'll get to the ECMA standard. So I don't know, negative 2. Well, that turned out really bad. It's really bad too. My hand like slipped and I went too far to the right. I guess it's a 2. That's good as I get for now. So I'm gonna get to program in. So yesterday, I spent the whole stream basically looking up the data types and stuff. I finally kind of like figured out how some of it works, and the rest later when I add more types. I got it to print the JavaScript whatever types, the internal types. And I have most of this loop converted. I got like this bottom part and then one of these chunks in here. So I'm going to try to finish converting it. I gotta find stopwatch to use. I might like convert it, get the loop ready, have it do like one pass, not loop though, and then speed test it tomorrow. Because I have I don't know, a little bit of anxiety. If I'm like fully awake, I don't know, I'll feel better tomorrow to like hit run, because I gotta set stuff up still. If I don't set everything up and something's messed up, I'm just gonna get annoyed. So I'm gonna like get stuff set up. Then tomorrow, if I can get all this up today, then I'll hit run and speed test it. When I have like starting off the day, not like when I'm tired and I'm like not in the mood to like yeah. So I'm gonna get Siri reading on ECMA, the modern standard for the modern JavaScript implementation on the modern operating system. First one, like this page, whatever. In the standard. It has this here.
Set all of the bytes of DB to 0.
So if you're gonna create a data byte block, I don't know what that is even. I don't know. I mean, like, I'd assume it'd give you like a block of bytes, but I don't know how that's different than an array, because I'm pretty sure they just make an array and call it a byte data block and lie. So I don't know why they'd, I don't know. This standard looks like they're technically supposed to give you a byte block or a block of bytes. That's what the standard says, but I'm pretty sure they don't. By they I mean other JavaScript implementations. I'm pretty sure that most other implementations are just gonna give you a normal array and pretend it's like a byte block.
Six, 2, 9, 1 create byte data block. Size. The abstract operation create byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a data block or a throw completion. It performs the following steps when called: if size 253.1, throw a range error exception. Let DB be a new data block value consisting of size bytes. If it is impossible to create such a data block, throw a range error exception. Set all of the bytes of DB to 0. Return DB.
Wow, that's weird. Imagine making an allocation that's not 64-bit. Within range. Why 53? I don't know why they picked 53. That's under 64-bit. Where is it, huh? I don't know, I'm confused. I might step out. But imagine making an allocation of memory. That's this large. 2 to 53rd minus 1. And then it looping through to set all the bytes to 0. That seems a little ridiculous. That's a whole lot of bytes to set to 0. Oh, I didn't copy. That's cool. The 53rd isn't really. They just format the text to make it look like it's to the power or raised. It's not really raised to the 53rd. And this is the modern operating system. I mean, like, modern computing has come so far. I can't believe how far we are in 2025. The capabilities and encoding schemes and stuff. It's just amazing how far we've come in the year 2025.
Hex conversion of subtraction. Google search.
I mean, even
Power of 3.
like 2025, text to chat doesn't even fucking work. It just like converts whatever the fuck it wants to chat or text to talk, whatever it's called. I don't know. This doesn't feel like the year 2025. Technology sucks.
Output of 5 like this raised to the power of 3. Ah, got it. You're asking to output the superscript form of the digit 5, like how raised to the power of 3 is the superscript for 3.
This is modern operating system. I guess limitations.
Unfortunately, Unicode does not include a standard superscript character for the digit 5. The Unicode standard includes superscripts for U plus 00B9 raised to the power of 2, U plus 00B2 raised to the power of 3, U plus 00B3. And additional ones in the superscripts and subscripts block, U plus 2070 U plus 209F, which include raised to the power of 2 raised to the power of 3, u plus 2070 u plus 2079. So, there is a superscript 5, it's...
So like I said, like, I don't know, it doesn't matter. So now we can ask chatbot. So need 53. So it's a 1 byte and 3 bits below a 64-bit number. That's a huge amount of memory. Let's check out how long it would take to set this many bytes to 0 in RAM. So if we made a byte data block to this size. It's weird that they put a size in the standard because they say like the size does like is independent, but clearly it's not, unless they're assuming 64-bit. I don't know. I still gotta read the fucking standard. Chatbot's like freaking out. They gotta like fix their website. Web design's rough. To make a website, you know, it's really difficult. That's a modern web design at the top there. The year is 2025. That's very modern. I don't know what the fuck it's doing. This computer has 24 gigs RAM, I think. This computer's not out of RAM. Oh, it's done now. It's 8 petabytes. There's a lot of memory. So this is how long it would take to based on the ECMA standard and the limit that they give. Or to creating a data block, byte block size, whatever.
Create byte data block. The abstract operation create byte data block takes argument size. If size 253.1, throw a range error exception. Let db be a new data block value consisting of size bytes. Set all of the bytes of db to 0. Return db. Set all of the bytes of db to 0.
There's ways to set things to 0 without actually setting them to 0. I'm pretty sure most people would take the standard and go, I'm literally going to set all the bytes to 0. I don't know, I want to see how long that would take, or what chatbot hypothetically thinks that would take, because chatbot can apparently think or something. It can't.
Memory size, you specified.
0x1ffffffffffffff plus 1 gleich 2 hoch 3 Bytes gleich 9,007, 199,254, 740,992 Bytes 8 Petabytes, pp.
Why did it switch to German?
You specified.
What the heck?
FFF 007.
What? That was weird. So if I read it as two separate, whatever, it stays as normal Siri.
FF. You specify.
If I read it as like a whole whatever block, it switches to German Siri.
You specified.
0x1ffffffffffff
What even?
gleich 2 hoch 3 Bytes gleich 9,007, 199,254, 740,992 Bytes 8 Petabytes, pp.
I like German Siri better. I'm gonna switch American Siri to German Siri because it sounds way cooler than American Siri. If you don't know German, eins is 1, zwei is 2, drei is 3. I don't know. I'll just switch it. It doesn't matter if you can understand or not.
Assumptions 1. Modern Ryzen CPU. Let's assume a Ryzen 9 7950X or similar, with DDR5 RAM. 2. Memory bandwidth. DDR5 at 6000 MTS. Dual channel. Gives 96 GB theoretical max. 3. Realistic memory throughput. Assume 80 GBs of actual zeroing throughput using optimized instructions like memset, SIMD, or repstos.
Do they still have repetition macros in x86, 64? I thought they got rid of the special instruction encodings.
Time estimation 9, 007, 199, 254, 740, 992 bytes 80 times 109 bytes s 112.6 seconds.
Oh my god, would you look at that?
9, 007, 199,
This thing sucks.
9, 0, 9, 9, 9, 9, 9,
What the fuck is up with this fucking thing?
9, 99007, 199, 254, 740, 992 bytes 80 times 109 bytes s 112.6 seconds. Street under 2 meters. Nine 007 199
Why is it reading the whole thing?
140 2 bytes 80 times 109 bytes s 112.6 seconds. Final estimate 113 seconds, just under 2 minutes, assuming optimal conditions, full memory bandwidth, and minimal overhead.
That's a long time. I gotta stop getting distracted and do something.
But in reality, no consumer CPU today has 8 PB of RAM. You're well into supercomputer or data center territory. Even mapping or simulating that much memory, for example with virtual memory, would incur major overhead. OS limits and virtual memory management would become the bottleneck long before raw memory speed. Note: in implementations, bytes is the result of a non-atomic read instruction on the underlying hardware. The non-determinism is a semantic prescription of the memory model to describe observable behavior of hardware with weak consistency. Let bytes be a list whose sole element is a non-deterministically chosen byte value.
Why do they need so many operations to like copy a data byte block? It's literally point A to point B with the length. Why does it take so much to like describe that?
The abstract operation copy data block bytes takes arguments to block, a data block or a shared data block, to int x, a non-negative integer, from block, a data block or a shared data block, from int x, a non-negative integer, and count, a non-negative integer, and returns unused. It performs the following steps when called.
For all the work that they put into like describing how to copy from A to B, from point A to point B, index, whatever, for length of bytes, I would have thought that like they'd be like, where it says here,
Set all of the bytes of DB to 0.
they'd be like, come up with some data structure to map what memory has been used or not, so it doesn't have to physically set all the bytes to 0 of the allocation, or make a standard where it could be garbage values, because setting all the bytes of new allocation to 0 is completely ridiculous. So I'm gonna have like a chatbot read this modern standard with modern thinking, and I don't know, it's very modern. And I'm gonna try to like convert the rest of the test loop, whatever, and speed test and compare it to the browser. I don't think I'm gonna run today, because I'm tired. So like, set everything up and check everything again and then run tomorrow. Let's have like a burst of energy, which I don't know. I'm not feeling it. I'm just tired. I need some water. I'll switch Siri to German Siri first, if it'll work.
Hallo, ich bin Siri.
Hallo, ich heiße Anna und ich bin eine deutsche Stimme.
Hallo, ich bin Siri.
Hallo, ich heiße Anna und ich bin eine deutsche Stimme.
Okay, so Anna isn't the same thing as Siri voice 2.
Hallo, ich bin Siri.
But I think Anna sounds better than Siri voice 2.
Ich bin eine deutsche Stimme.
I had it held down, but I gotta play it again. This is Siri voice 2 and then Anna.
Hallo, ich bin Siri.
Hallo, ich heiße Anna und ich bin eine deutsche Stimme. Hallo, ich heiße Anna und ich bin eine deutsche Stimme.
Hallo, ich bin Siri.
I'm gonna go with I don't know. I'm just gonna call it Siri though. It's the same thing.
Hallo, ich heiße Anna und ich bin eine deutsche Stimme.
I'm gonna have Siri read this. I'm gonna try to convert code and stuff.
6.2.9.
Ah.
Block size. The abstract operation create byte data.
It didn't do Siri voice too or Anna. It just did like this robot voice that sounds like a ripoff of Stephen Hawking's. Because Stephen Hawking's was a ripoff anyways. I'm pretty sure he died years ago. That wasn't him. It was like a puppet or something. Because he was dead. There's no way he had the disease that he apparently had and it survived for that long. Anyways, I guess you could call that a conspiracy or whatever. I don't give a fuck. I'm not stupid. I'll just keep this Stephen Hawking's voice. I'm gonna Google Stephen Hawking's really quick.
Block takes argument size, a non-negative integer, and
You literally saw me click here in settings. I click accessibility. I clicked voiceover. Spoken context. It says Anna fucking right there. It says Anna. It doesn't say Mr. Stephen Hawking's ripoff voice. It says fucking Anna. But it gives me this.
returns either a normal completion containing a data
The fuck? This is literally the modern operating system. It's about as modern as it can get. So I'm gonna look up Stephen Hawking's really quick. Then I'm gonna focus and try to work.
or throw completion. It performs the following steps when called. If size greater than 253, 1, throw a range error exception. Let db be a new data block value consisting of size bytes. If it is impossible to create such a data block, throw a range error exception. Set all of the bytes of db to 0. Return db.2.9.2 create shared byte data block size. The abstract operation create shared byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a shared data block or throw completion. It performs the following steps when called. Let db be a new shared data block value consisting of size bytes. If it is impossible to create such a shared data block, throw a range error exception. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution. Whose is agent signifier. Let 0 be 0. For each index I of db, do a. Append write shared memory. Init. True. db. I. 1. 0 to events record. Return db.2.9.3 copy data block bytes to block to index from block from index count. The abstract operation copy data block bytes takes arguments to block a data block or a shared data block to index a non-negative integer from block a data block or a shared data block from index a non-negative integer and count a non-negative integer and returns unused. It performs the following steps when called. Assert. From block and to block are distinct values. Let from size be the number of bytes and from block. Assert. From index plus count less than or equal to from size. Let size be the number of bytes.
This is some bullshit. Alright, so ALS, okay.
The average life expectancy after an ALS diagnosis is typically between 2 to 5 years, though some individuals can live for much longer. About 10% of people with ALS live for 10 years or more, and a small percentage, 5%, survive for 20 years or longer. Factors like age at diagnosis, onset of symptoms, and type of onset can influence life expectancy. Exceptions. Some individuals, like Stephen Hawking, have lived for decades with ALS.
Are you fucking kidding me? only one guy lived for decades with ALS. That's some total bullshit.
Very few people survive decades with ALS, as it's typically a rapidly progressing disease. However, there are some rare and remarkable long-term survivors, like Stephen Hawking. Here's a short list of others who have lived unusually long with ALS.
What's this? 18 years? That's nowhere near 55. This is realistic. 55 years? That's some bullshit. I gotta stop wasting time. I don't think he was alive for that long. He had like a puppet or something. I don't believe it. I'm gonna have a Siri, or I mean, rip off Stephen Hawking's read ECMA. I'm gonna try to get it to work with the Siri voice though.
Hallo, ich bin Siri.
Meth. 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 Finding concrete method of a module environment
Why the heck is it not?
The follow. Binding concrete method of a module environment record in rect takes no arguments and returns true. Following step.
I'm gonna just settle for this. It's close enough. It's better than robot Stephen Hawking's. It seems like it picks the second last one that was picked every other time. And it only gets like the voice that I pick. Like never. Every once in a while it gets it, but it keeps like reverting back to some other voice in the menu. I have no idea. I'll just, whatever voice it is right now, as long as it's not robot ripoff Stephen Hawking's, I guess I'll just keep this voice.
9115 has binding. The has binding concrete method of a module environment record in rect takes no arguments and returns true. It performs the following steps when called. Return true. 1154 get this binding. The get this binding concrete method of a module environment record in rect takes no arguments and returns a normal completion containing undefined. It performs the following steps when called. Return undefined. 1155 create input binding n, m, n2. The create input binding concrete method of a module environment record in rect takes arguments n, a string, m, a module record, and n2. a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in MC module environment record. Access to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called. Assert, env does not already have a binding for n. Assert, when m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in env for n that references m in n2 as its target binding, and record that the binding is initialized. Return unused. 1-2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9 second 1 jetted interference env, name, strict. The abstract operation jetted interference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record, or a throw completion. It performs the following steps when called. If env is null, then return the reference record, unresolvable, name, strict this value, empty, let exists be, the env.has binding, name. If exists is true, then return the reference record, env, name, strict, empty, else. 150 ECMA International 2024. Note: module environment records always provided this binding. A b let outer b env. Return jetted interference outer name strict. 9 second 2 new declarative int e. The abstract operation new declarative int takes argument e, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to e. Return env. 1 second 3 new vect invite environment OWE. The abstract operation new vect invite environment takes arguments o, an object, w, a boolean, and e, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to o, set env to w, set env to e, return env. 1 second 4 new function envi environment, f new target. The abstract operation new function envi environment takes arguments f, an ECMAScript function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to f. If f is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to f. Return env. 1 second 5 new global environment. G this value. The abstract operation new global environment takes arguments g, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let JavaScript be new vect invite environment g, false, null. Let select be new declarative int, null. Let env be a new global environment record. Set env to JavaScript. Set env to this value. Set env to select. Set env to a new empty list. Set env to null. Return env. 1 second 6 new manager environment e. The abstract operation new manager environment takes argument e, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to e. Return env. ECMA International 2024151. 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMAScript code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, OTA private enant vi tenant, private environment record or null. the private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names, the private names declared by this class. 921 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 92 First one, new private environment, autoprevenv. The abstract operation new private environment takes argument autoprevenv, a privatenvironment record or n, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record, autoprevenv. Names, first to resolve private identifier, prevenv identifier. The abstract operation resolve private identifier takes arguments prevenv, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be prevenv. For each private name pp of names, do if pn is identifier, then I return pn. Let autoprevenv be prevenv. Assert, autoprevenv is not null. Return resolve private identifier, autoprevenv, identifier 3 realms. Before it is evaluated, all ECMAScript code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24. 52, Copyright Sign, ECMA International 2024. Table 24, Realm Record Fields. Field Name, Agent Signifier, Intrinsics, Global Object, Global Env, Template Map, an Object or Undefined Value, an Agent Signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are, a string, and a module record. NOT1 Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything, default value is undefined. NOT2 as mentioned in Hoslo add imported module, 16.218 Note 1, in realm records, is only used when running an import expression in a context where there is no active script or module, field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated value is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 931 criterion. The abstract operation criterion takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform crete intrinsics, realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024153 932 crete intrinsics, realm rec. The abstract operation crete intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in Column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name, property. Length is the initial value of the function's length, property. Slots is a list of the names, if any, or the function's specified internal slots. and prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restricteds, realm_rec, return unused. 3 set realm_global, realm_rec global ob this value. The abstract operation set realm_global takes arguments realm_rec, a realm record, global ob, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If a global ob is undefined, then a let intrinsics be realm_rec. B set global ob to ordinary object crib, intrinsics. Assert global ob is an object. If this value is undefined, set this value to global ob, set realm_rec to global ob. Let no globalin be new global environment. Global ob, this value, set realm_rec to new globalin, return unused. 3 set default globines, realm_rec. The abstract operation set default globines takes argument realm_rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm_rec. For each property of the global object specified in clause 19, do a let name be the string value of the property name. B let desc be the fully populated ta property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm_rec. C perform, define property throw, global, name, desc, return global. For execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25, State components for all execution contexts. Component purpose code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code access ECMAScript resources. Script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context, created in initialize defined refined reasm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last in, first out manner. However, some ECMAScript features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Table 26, Additional State Components. For ECMAScript code execution contexts. Component purpose lexical event. identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable state sets within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical env and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024155. Table 27, Additional State Components, for generator execution contexts. In most situations only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence when the terms lexical env and variable environment are used without qualification they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. For one JetActiveScript the abstract operation JetActiveScript takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module, based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. For to resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record, or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then assert env to the running execution context's lexical env. Assert env is an environment record. If the source text matched by the syntactic production that is being evaluated is counter init in strict mode code, let strict be true, else let strict be false. Return jetted interference env name strict. For 3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical env. 2. Repeat component purpose generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env. Has this binding. If exists is true, return env. Let outer be env. Assert outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4th. For resolve thinding. The abstract operation resolve thinding takes no arguments and returns either a normal completion containing an ECMAScript language value, or a throw completion. It determines the binding of the keyword this using the lexical env of the running execution context. It performs the following steps when called. Let envrec be get this environment. Return envrec.get this binding. 4th. 5. Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical env of the running execution context. It performs the following steps when called. Let envrec be get this environment. Assert envrec has a field. Return envrec. 4th. 6. Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2. 5. Let current realm be the current realm record. Return current realm. Jobs and host operations 2 in queue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hooks host-enquete generic job, host-enquete lineup, host-enquete premise job, and host-enquete ETIME-out ABAP to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure in a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If a null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024157. NOTE1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Jet active script or mul is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object in a host-defined value. Function objects that are invoked via a job include by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host-make-a-job in host call job callback. Job callback records have the fields listed in Table 28. Table 28, Job callback record fields. 5.2 Host-make-a-job callback. The host-defined abstract operation host-make-a-job takes argument callback, a function object, and returns a job callback record. An implementation of host-make-a-job must conform to the following requirements. It must return a job callback record whose field is callback. NOTE2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific coach E of realm is up to the host environment. This initial execution context in realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context in realm. Note the WHAT HTML specification, https://html.spec.what.wg.org/. For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name value meaning callback a function object. The function to invoke when the job is invoked. Host-defined anything. Default value is empty. Field reserved for use by hosts. 158 ECMA International 2024. The default implementation of host-make-a-job performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMAScript hosts that are not web browsers must use the default implementation of hostmaker. 5.3 Host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value, or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call, job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert, equalable, job callback, is true. Return, call, job callback. V. Arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback. 5.4 Host enquete generic job realm. The host-defined abstract operation host enquete generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enquete generic job must conform to the requirements in 9.5. 9.5.5 Host enquete promise, job realm. The host-defined abstract operation host enquete promise takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enquete promise must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked the implementation must be. A reform implementation defines steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be jet active script or mul. At the time host enquete promise is invoked, if realm is not null, each time job is invoked the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enquete promise invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise.the action calls make job callback on the action at the time of invoking promise.pro to type.the not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior or function objects defined in this specification. ECMA International 2024-159. NOTE The realm for jobs returned by no premise or lethenib is usually the result of calling get function realm on the then function object. The realm for jobs returned by no promise action job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, i.e. called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, e.g. error objects, will be created. The WATAG HTML specification, https://html.spec.wat.wg.org/ for example, uses realm to check for the ability to run script and for the entry less than https://html.spec.wat.wg.org/ #entry. Concept 5.6 Host enquete etimeout arbab. Time utiab, realm, milliseconds. The host-defined abstract operation host enquete etimeout arbab takes arguments time utiab, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules time utiab in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enquete etimeout arbab must conform to the requirements in 9.5. 9.6 Initialize defined refined reason. The abstract operation initialize defined refined reason takes no arguments and returns either a normal completion containing unused, or A through completion. It performs the following steps when called. Let realm be create a realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Performs the realm global, realm, global, this value 0. Let global be, set default globines, realm 1. Create any host-defined global object properties on global ob 2. Return unused 7 agents. An agent comprises a set of ECMAScript execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note: some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29, Agent Record Fields. Field name value meaning Little Indian, a boolean. The default value computed for the is Little Indian parameter when it is needed by the algorithm's getValue from buffer and setValue in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean. True if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2. A boolean. True if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean. True if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values are and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of an are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field for byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic access of size n. Specifically, non-atomic access may still be performed as a sequence of several separate memory access. See read Sharid Mori and write Sharid Mori for details. ECMA International 20244161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR. 7th. To agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2. 8. Let AR be the agent record of the surrounding agent. Return AR. Agent clusters. Note: in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly, for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. NOTE1 programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. NOTE2: the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. NOTE3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. NOTE4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster: candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. NOTE5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents when PA agent resource accounting indicates that the agent is run away. NOTE6 all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. NOTE7 an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 9 Forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. 10 Processing model of weakref and finalization targets 9101 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weakrefs and finalization registries is based on two operations which happen at particular points in time. When weakref.pro2type.ref is called, the referent, if undefined, is not returned, is kept alive so that subsequent, synchronous access also return the same value. This list is reset when synchronous work is done using the clearKept object's abstract operation. When an object or symbol which is registered with the finalization becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made. After synchronous ECMAScript execution completes, the finalization cleanup is performed with the cleangealization register view and register abstract operation. Neither of these actions, clearKept objects or cleangealization register view and register, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, this specificat differs the scheduling of clearKept objects in cleangealization register view and register to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleangealization register view and register allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols as a hypothetical weakref oblivious execution with respect to S is an execution whereby the abstract operation weakref of a weakref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sexet writes note eventually become observable to all agents. NOTE1 weakref obliviousness, together with liveness, capture two notions. 1. That a weakref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining VV's liveness depends on determining the liveness of a weakref referent, RS liveness cannot assume VV's liveness, which would be circular reasoning. NOTE2 weakref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weakref referent in a cycle will be considered live even though its identity is only observed via the weakref reference in the cycle. NOTE3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agent's list. 164. ECMA International 2024. There exists a valid future hypothetical weakref oblivious execution with respect to S that observes the identity of any value in S. NOTE4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weakref means. A value's identity may be observed by observing a strict equality comparison, or observing the value being used as key in a map. NOTE5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as in fields of a finalization cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. NOTE6 liveness is the lower bound for guaranteeing which weakref's engines must not empty. Liveness as defined here is undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each week ref such that ref is value. Do I set ref to empty. B for each finalization fg such that fg contains a record cell such that cell week ref target is value. Do I set cell to empty. 2. Optionally, perform host enquy lineup fg. C for each week map such that map contains a record r such that r is value. Do I set r to empty. 2. Set r to empty. D for each week set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024165 NOTE1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited. Because calling host enquy lineup is optional, registered objects in a finalization do not necessarily hold that finalization live. Implementations may omit finalization callbacks for any reason, e.g., if the finalization itself becomes dead, or if the application is shutting down. NOTE2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v. 10.4 Host hooks. 10.4.1 Host enquy lineup. Finalization. The host-defined abstract operation host enquy lineup takes argument finalization registry, a finalization, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization and performs the following steps when called. Let cleanup result be completion, cleaniginalization register view in registry, finalization. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error, return unused. An implementation of host enquy lineup schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11, clearkept objects. The abstract operation clearkept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clearkept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024 9.12 Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 13. Cleaniginalization register view in registry. Finalization. The abstract operation cleaniginalization register view in registry takes argument finalization, a finalization, and returns either a normal completion containing unused, or a throw completion. It performs the following steps when called. Assert, finalization has an internal slots. Let callback be finalization. While finalization contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization. C perform.
I used pointer tagging in my JavaScript engine, and then later on, I don't know, I don't do pointer tagging anymore because you're kind of stuck with what you do when you do it. Like you're stuck to memory of a certain alignment, and it's kind of annoying because you tag the pointer expecting it to be aligned, and you have to always like zero out those bits or whatever to align it to the data that it points to, whatever. So like on newer stuff, I keep the address separate, and then bytes, whatever, next to it that hold like data related to the address, and that ends up being slower. Pointer tagging is like way faster, but it has the complexity of like you're stuck with like aligned memory, and you can only tag, you can only represent so many bits within the pointer, and you're like stuck with it after. But it's like significantly faster to pointer tag than to make a separate data structure. I should have used pointer tagging in some of the new stuff I did. But it's not good because pointer tagging, you end up with like really complicated code, and it like everything ties together, whatever, and you can't like untangle it easily. But JavaScript, whatever, or some implementations of JavaScript, they use pointer tagging, and commonly, a lot of times, people pointer tag to the size t. So 32-bit has 2 bits, no 0 if it's aligned to 32-bit. So they got 2 bits to pointer tag, and I did that too in my JavaScript engine before I knew it was called pointer tagging. Then I found out it's called pointer tagging. Updating to 64-bit means I'm going to have 3 bits instead of 2 bits. And I have to figure out what to do with that extra bit. If I want to like use that bit to indicate some like extended encoding, I could expand it to like represent 4 more options in like the hash table that I had. I didn't do pointer tagging, I did something different with aligned memory stuff. But I want to like separate the standard arrays from the hash table or hash map, whatever you want to call it, map to memory structures. I got 1 bit that's not used because it was for 32-bit, my JavaScript engine, now 64-bit. I have 1 bit left. when I run the speed test, whatever, I'm like, it's going to be faster than the current JavaScript implementation. But when I add hash maps, sparse arrays, maps, data maps, whatever you want to call it, I'm going to get a speed drop because there's extra layers of memory in tables you have to go through because you bucket the parts of the address or the number to access to it. So it gets slower. So I'm going to lose the raw array speed performance. So I think I want to use a bit and pointer tag to specify when it's an array or a hash map, and then an if or whatever, depending on the compiler, usually fall through, which is when it's a true case inside of the block of the if, is the fastest outcome because the jump isn't taken, and then the jump after the if, depending on if there's an else, whatever. That way I can test a bit for when it's an array. It'll follow through the conditional test and not take the branch, accesses an array, and then there's a direct jump after it to go over the code under it, and then in the else I'll put the hash table lookup stuff when it's a hash map. So that way it's called static branch prediction. Even the high level CPUs use static branch prediction, and then there's branch buffer lookup table, whatever, BLT or BTL, branch target buffer, that's on top of the static branch prediction. But if you meet the static branch prediction the first time, you're pretty much guaranteed the next time if it does enter that prediction, it'll be predicted you're going to enter again unless it's false. Okay, so basically I can set it up so that the normal like array accesses when it's an array will be faster, like how this has to be faster, because it won't be a hash table. The hash table will take the else case, and the performance drop of taking the else case will be smaller because the true case has the normal array access, which means there's less operations in the true case, so there's less code that has to be branched over when the condition is met that has to take the branch. So I don't know, I can like get a whole bunch of benefit out of doing that, and then I can get near the same performance of using plain arrays, but also supporting hash maps for the new stuff. And I get like the best of both or whatever. Then the overhead is minimal when it takes the branch to do the else case, which has the hash map stuff, because the amount of code between the if and then the else to choose between the two, the array access or the hash map access, the array access is much smaller code, so the pipelines are dropped, but it wasn't that large, and it's a smaller bubble in the pipeline. And then when more things are arrays, like array access, which would be for a video game, or things that are more performant based, people aren't going to use hash maps or random indexes into an array at a weird, really large offset or whatever. it'll have higher performance or throughput, whatever, if most things are raised on 2, or if most things are hash maps, the branch predictor will most likely remember, as long as I split up the code and have enough distance between branches that the branch predictor can keep track of the separate branches. It'll have an easier time of if the branches are too close together in memory where they store the branch table prediction, they can mangle. So if there's like 2 jumps, conditional jumps, they're next to each other, they'll both get the same case in memory. So if one's always false and other one's false sometimes, they like mix together, you can mess it up. But if there's like instructions in between the 2, okay, I don't know, whatever. So I think I'm gonna do that with the extra bit that I have for pointer tagging, whatever. I was gonna use it. I don't know if I'm gonna do that. I gotta like, I don't know, I'll just have check out read pointer tagging. I gotta convert this loop still. I'm just thinking ahead or whatever.
Pointer tagging, also called tagged pointers, is a technique used in low-level programming, especially in languages like C, C++, and in virtual machines like those for Java, Python, or Objective-C runtimes, to store additional information, metadata, in unused bits of a pointer without using extra memory. How it works: modern computer systems typically align memory addresses. For example, on a 64-bit machine, memory is often aligned to 8 bytes, meaning the last 3 bits of a pointer are always 0. These unused bits can be repurposed to store metadata such as
I think it means thirst, 3 bits. I don't know. Chatbot's kind of backwards.
3 bits. These unused bits can be repurposed to store metadata such as type information, e.g., integer versus float. Marking pointers as special, e.g., tagged for garbage collection.
Tagging a pointer with a bit for garbage collection is really stupid. It's really dumb. It's like, I don't know. You should move something to be garbage collected to somewhere else, not tag it. I guess tagging it for garbage collection could be useful, but then you have to like find it. Because why would you tag it if you already found it and moved it somewhere? It means you're probably leaving it. So when it comes up again or you happen to see it, you can decide what you're going to do with it because you tagged it, but you didn't do anything to a garbage collector yet. I don't know. I guess it could make sense to tag something for garbage with a bit, but it seems like doing that's like an afterthought.
Indicating small objects or immediate values, e.g., small integers, null values. Immediate values.
I don't think that counts as an immediate value to put, because it's stored to memory. An immediate value is typically like a value that's in code memory that's assigned to a register, not a data value that has bits. I don't think technically that counts as a immediate value. Maybe it does.
Example: suppose you have a 64-bit pointer, but the system aligns memory to 8 bytes. That means the last 3 bits are always 0. So you could
I don't know why chatbot says the last 3 bits. And then it shows 0x07. That means it's the first 3 bits. Independent of little endian or big endian. Endian. Or Indian. I don't know. It's end, Ian. The word is END-IAN for endiness and idness. I don't know, it's a stupid word to say if it's stored lowest significant to most significant or most significant bit to least significant bit.
use the last 3 bits to store tags. Mask off those bits when accessing the real memory address.
I'm going to ask chatbot if this hexadecimal value is the first 3 bits of a number. Wait, what? The zoom tool on the Mac works so much better than Windows 11. Windows 11 is a turd, like a real freaking turd. Okay, so 0x07 is 3 bits. PC 1, 2, 3. 0x07. This is the first 3 bits of a number. This is bit 63. This is verse 3. Chatbot says, Chatbot says last 3 bits. So chatbot doesn't know what it's saying because chatbot isn't intelligent. Chatbot, it can't think. Chatbot just pulls text from a text blob called training data. Chatbot is not artificial intelligence. And chatbot does not have a consciousness. Anyone that thinks that is freaking stupid. Oh, chatbot's correcting me. It's saying it's the lowest. So I'll say, is it the last 3 bits? So is 0x7 the last 3 bits? Well, that's confusing. That's really confusing. It says 0x7 corresponds to the last 3 bits, the least significant bits. Least significant bits would be the lowest bits. But it says the lowest 3 bits are not the first 3 bits of a pointer. I don't know. I'm not gonna argue with chatbot. Chatbot wins. Okay, just want to chat about this. Who reads binary from left to right? Oh, because they're talking about significance, not in position of memory. So this isn't pointer tagging. We off. Okay, up here.
In pointer tagging, we often work with the rightmost, least significant bits like bit 0, 1, and 2, because they're usually unused due to alignment. Bit 0 is the rightmost.
Okay, so bit 0 then must be the rightmost, and it is the last 3 bits of a pointer.
Excellent question. You're touching on a really important concept, numerical value versus bit position. Zero times 07 SETS bits 0, 2, the lowest, least significant bits.
Okay, so right here it says the last 3 bits of a pointer. So if the last 3 bits of a pointer are always 0, if those are the low bits, okay, so I think I have a way to word it now. Chatbot says this right. So I'm gonna make this make sense with Chatbot. I mean, I don't know why I'm arguing with Chatbot. I'm just gonna agree with Chatbot from now on. Okay, so this is true because Chatbot says,
Yes, you're absolutely right, and this is a great realization.
okay, so this is a great. Just listen how great this is.
So the last, meaning the last 3 bits of a pointer are always 0, are the low bits, then first bits means not the first 3 bits but the higher bits of a number?
Yes, it must be true.
Summary. Last 3 bits or number refer to the lowest bits, bit positions 0, 1, and 2, also called least significant bits, LSBs. First bits, in this context, typically mean the highest bits, bit positions 63, 62, 61, also called most significant bits, MSBs.
So there we go again with
Context.
it's all about.
Context.
Because based on the
Context.
anything could be true or false, depending entirely on context.
Context. Why the confusion? The terms first and last are sometimes ambiguous because, in natural reading, we think left to right, first, equals leftmost, but in memory or bit math, the significance matters more than visual order.
Because this makes a lot of sense right here.
So the last, meaning the last 3 bits of a pointer are always 0, are the low bits, then first bits means not the first 3 bits but the higher bits of a number? Yes, you're absolutely right, and this is a great realization. Better terms to use, for clarity. So yes, when we say, the last 3 bits are 0, in pointer tagging, we mean the lowest order bits, bits 0, 2, not the first bits you might read left to right.
Okay, you get that? So it depends on context. So even though
The last 3 bits.
they mean
The lowest order bits.
because the last is the lowest. Kind of like the first shall be last. I'm gonna get to programming. I can't waste any more time. It's broken. Oh no, no. What the heck? Testing, testing. Let me not working.
Binding property, singular name binding. Let name be the sole element of the bound names of singular name binding. Perform keyword indigenization of singular name binding with arguments value, environment, and name. Return name. Binding property name. Bind engelment. Let P be evaluation of property name. Perform keyword indigenization of bind engelment with arguments value, environment, and P. Return P. 4332 Runtime semantics, REST indigenization. The syntax-directed operation REST indigenization takes arguments value, an ECMAScript language value, environment, an environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion, containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding REST property. Binding identifier. Let ls be resolve binding, string value of binding identifier, environment. Let restob be ordinary object crib, %object.pro, to type %. Perform copy data properties, restob, value, excluded names. If environment is undefined, return pot value, LHS, restob, return initial easy bin, ls, restob, 4333 Runtime semantics, keyword indigenization. The syntax-directed operation keyword indigenization takes arguments value, an ECMAScript language value, environment, an environment record or undefined, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Bind engelment, binding pattern initialize, let v be GTV, value.
I'm converting this JavaScript whatever. And I just realized since last time why the loop I don't like recognize things until way after the fact because I'm like 10 steps ahead of what I'm trying to do. But
Value, property name, if initializer is present and v is initializer is true, then I set v to named a derivation of initializer with
this loop whatever.
passed for environment. It indicates that a pot value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are
I'm converting it whatever to run on my JavaScript engine. I bit my tongue a couple days ago. It still hurts. I can talk better. I'm not saying tongue weird, but it still hurts to talk. I need some more water. But
S. Evaluation. Empty.
last time I was like, how the hell is this loop not affecting the speed of this speed test? And I was like all pissed off. I'm like, what the heck? And then right now I realize that I end the stopwatch, the time, right here, and then I run the second loop, which means that I only timed the speed test at this point and everything before it, which is up to here, where it gets the time the first time. So I get the time here, and I get the time here. Oh, the fucking lag. So laggy. I get the time here. And I get the time here. And I subtract.
Expression plus in.
To get the elapsed time
Head else. The look ahead.
that occurred between these 2 points. Which means that this loop here, it's not inside of the 2 times subtracted to get the elapsed time. So no wonder this loop wasn't affecting the overall time. It was because it wasn't between where I was taking the time. So I'm going to I don't know. I didn't realize it till right now. I'm like, oh fuck. There's a couple other things that are possibly wrong. Not wrong, but aren't, I don't know. This is like a crap function in the first place. But there will be a difference in time. I gotta make a better speed test loop. I had Chatbot make it, and I kind of like modified it a bit. So if anything, it's a real example of crappy code to run for speed testing. But the difference in time should be drastic enough that mine's still like so much faster that even though time fluctuates
Up the team.
from like 1,303 milliseconds, if it's milliseconds, I don't know what time this is measured at,
Turn. 4 state.
even though if it fluctuates between 1,303 and 1,606, 1,627, mine should be, my JavaScript engine should be so much faster than this. It's nowhere even near 1, 2, 3, 4, like, it should be like way faster. So I don't know.
Following steps when called.
I'll just not change the loop. I'm going to compare what I have against what I tested with this. I'll make different loops whatever later test. So I don't know. I just realized that way after the fact that that's why the loop speed wasn't affected at the time test, because this loop was outside of it for its timing, which is why when I put 0 in here, it wasn't affecting the time because it was outside of the timed area. which means that the browser may actually optimize for this. And I'm thinking it will. The last time it didn't, I was really confused. I was like, what the hell is going on? So I don't know. I'm gonna try to finish converting this stuff, and this kind of makes sense now. I just realized,
For an
like after effect. Is that hindsight? I don't know, whatever.
do a while statement, yield, await, return, do statement, yield, await, return, while, expression, plus in, yield, await, 4721 static semantics, early errors. Do a while statement, do statement while, expression. It is a syntax error if is labeled function, statement, is true. NOTE it is only necessary to apply this rule if the extension specified in B31 is implemented. 14722 runtime semantics, do while loop evaluation. The syntax-directed operation do while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value, or an abrupt completion. It is defined piecewise over the following productions. Do a while statement, do statement while, expression, let v be undefined. 2. Repeat, a let's empty salt be completion, evaluation of statement. B if loop continues, empty salt, label set, is false, return, update empty, empty salt, v, see if empty salt is not empty, set v to empty salt. D let express b, evaluation of expression. NOTE within the statement part of an iteration statement, a continuous statement may be used to begin a new iteration. Copyright sign, ECMA International 2024301, let express value b, get value, express, if to boolean, express value, is false, return v. 4733 while statement syntax. While statement, yield, await, return. While, expression, plus in, yield, await.
I'm gonna look up pointer tagging in the browser. I can't focus.
Statement, while, expression, statement. It is a syntax error if is labeled function, statement is true. NOTE it is only necessary to apply this rule if the extension specified in B31 is implemented. 14732 runtime semantics, while a loop evaluation. The syntax-directed operation while a loop evaluation.
If I use a bit for pointer tagging for when it's an array or a hash map,
Language value, or in
then I can have it strategically change to a hash map when indices are set or above the array size, and then I can remap that array to the beginning of the hash map and then fudge the hash map to a line after the array, so that accessing the array through the hash map will be the array access time through the hash map when it's accessed from the base to the length of the original array, and then values added after the array extended will use the hash map, and then after the array settles down, nothing's assigned to it, and it doesn't look like, it's not predictable if another indice is going to be set above or below whatever the last one that was set was in the array. I could have it, the hash map, whatever, stored in a collection of other hash maps that are being resized but are array-like, and then I can have it automatically loop through that collection of hash map like arrays, and then make a new array by making the allocation the size of the old array in the hash map with the extended values that were set beyond the original array that are part of the hash map, and it could loop through and then assign to resize the array but to a new array the extended memory, and then keep the old values of memory, whatever, and then it can set the bit off to indicate that it's an array again and no longer a hash map, and then the hash map memory could be reclaimed or whatever for other hash maps. So I don't know. that's what I was gonna try to do. But that's like optimizing, so I would do that after I meet the standards, whatever. I'll do optimizing. For now, I don't know, whatever. I'm just thinking, I think that'd be like the best way to handle it, so that arrays get array speed. And for resizing it might be best too, because when resizing and you're appending, you're going to keep adding things to the array. They'll most likely be in the same bucket, because you're like going indice, increasing. And that block of memory of the slab will most likely be memory for a little bit, so we can like save that address. So when accessing the hash table, I can check if it's in range and continue accessing that spot without having to go through each layer of the hash map, and then only have to go through each layer of the hash map when you're accessing a location that's not part of the cluster that was recently accessed. And I can even save maybe like 9 or 10 or 12, not 16. I could save a certain number of addresses that hold the lookup, so it doesn't have to go through the whole lookup for a few of the most commonly, like the hotspots that are accessed inside of the hash map or whatever.
B else I perform. Lupin dot create a mute binding.
I don't know, here's the V6 whatever, JavaScript V6. I don't know if it's V8, whatever it is, how they do pointer tagging. I did it different or whatever. I don't think this is the best way to do it, or the best way to use pointer tagging for. That's just my opinion.
Otherwise let per iteration let's be a new empty list. 0. If the first expression is present, let test be the first expression, otherwise, let test be empty. 1. If the second expression is present, let increment be the second expression, otherwise, let increment be empty. 2. Let body result be completion. For body evaluation, test, increment, statement, per iteration let's, label set. 3. Set the running execution contexts lexical env to olden. 4. Return, body result, copyright sign, ECMA International 2024303 14743 for body evaluation, test increment set aimed per iteration binds label set. The abstract operation for body evaluation takes arguments test, an expression parse node or empty, increment, an expression parse node or empty, set aimed, a statement parse node. Per iteration binds, a list of strings, and label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let v be undefined. Perform. Create per iteration invite ion environment. Per iteration binds. Repeat. If test is not empty, then let test ref be. Evaluation of test. 2. Let test value be. Get value. Test ref. 3. If to boolean, test value is false, return v. B. Let result be completion. Evaluation of set aimed. See if loop continues. Result. Label set is false. Return. Update empty. Result. V. D. If result is not empty, set v to result. E. Perform. Create per iteration invite ion environment. Per iteration binds. If increment is not empty, then I let incref be. Evaluation of increment. 2. Perform. Get value. Incref 4744 create per iteration.
I don't think they know what branchless code is.
Normal completion containing unused or a throw completion. It performs the following steps when called. If per iteration binds has any elements, then a. Let last iter atnenv be the running execution context's lexical event. B let outer be last iter atnenv. C assert outer is not null. D. Let this iteration f be no declarative event. Outer, e for each element ebn of per iteration binds. Do I perform this iteration of dot create a mute binding. Bn false. 2. Let last value be last iter atnenv dot get binding value. Bn true. 3. Perform this iteration of dot initialize binding. Bn last value f set the running execution context lexical event to this iteration f return unused. 04 ECMA International 2024 1475 The for in, for or, and for await of statements syntax. For in of statement, yield, await, return. For, look ahead let, left threads to the expression, yield, await, in, expression, plus in, yield, await, statement, yield, await, return. For, var for binding, yield, await, in expression, plus in, yield, await, statement, yield, await, return. For declaration, yield, await, in expression, plus in, yield, await, statement, yield, await, return. For, look ahead, let, async or, left threads to the expression, yield, await, or assignment expression, plus in, yield, await, statement, yield, await, return. For, var for binding, yield, await, or assignment expression, plus in, yield, await, statement, yield, await, return.
Okay, so the sign extended a 32-bit value to 64-bit.
Wait, return, plus await.
Moving
Assignment text.
the lower 32 bits of R11 into R10.
Turn, plus await, for await, var for binding, yield, await.
Isolating bit 0.
Statement.
So they move to R10. R11. Why? What's the point? Why the fuck would they sign extend it if they're just gonna keep the lower 32 bits anyways?
Binding, yield, await.
Oh, we're adding later. So in the end, they add to R11, R10. So the sign extending R11, which is the original value, we'll just call it X. So they set X at 32-bit or lower to R11. They sign extend it, so the upper bits are all 1 or all 0, matching the sign bit.
Of assignment.
They move to R10, the low 32 bits.
Of assignment.
So R10 is the low 32 bits, or R11, which is X.
And for await.
The AND with R10, 1 to keep bit 0.
Function, state.
To negate R10,
3 to apply the.
which means that R10 is set to 0, or kept as 0 when negated, or it's set to -1 when it's 1, because the negated value of 1 is -1, and the negated value of 0 is 0, because assigned to arithmetic, there is no -0, so when you make 0 negative, it's still 0. So they negate 0x1 to intentionally get the register of R10 to all 1s or all 0s.
Statement 4.
Why don't they just move the bottom byte of the value? Why move 32 bits if I'm going to keep 1 bit?
If the bound names of for declaration contains, let. It is a syntax error if any element.
Okay, so anyways, they negate it. So they get 0 or -1, which is all 0 or all bit set.
The for declaration contains any duplicate entries. 4752 static semantic.
And that with R13.
And return.
I don't know what's in R13.
Productions. Member expression, primary expression. If primary expression is either an object, a literal, or
Or what the point is of R13, because you don't even use. Oh, wait for you. Okay, so R13 is some value. It could be 10, 20, 15, who knows. But they're ANDing that. So when you AND that, you AND 0 with R13, you get 0, because 0 and anything is 0. Well, if you AND -1 with F13, you'll keep all the bits that are set in R13, therefore keeping value.
and 1. Return
And then at the end of all that, they add
B5.
the quad word, I think. I think that means all, that means 64-bit, I guess.
For declaration.
They add to R11, which was originally set to X, that was signed extended, R10, which now holds whatever R13 was, based on if it's true that the bottom bit of R10 was on or off after the negation and the AND to keep the value only when it was all on.
6. For declaration binding instantiation.
So overall, they're adding to R11
X argument
whatever was in R13
and returns on
based on if the bottom bit of X, the original value that was signed extended to R11, had its bottom bit on or off.
environment.create immutable binding. Name, true. B else, I perform. Environment.create immutable binding. Name, false. 2. Return a new. Semantics, for enough loop evaluation. The syntax-directed operation for enough loop evaluation takes argument label set, a list of strings, and
So like Chatbot said. So Chatbot's right.
completion. It is
I don't think this is the most optimal way to write this.
definition, statement, let key result be foreign, OFED evaluation, expression, enumerate, return, foreign, off-board evaluation, left the expression, statement, key result, enumerate, assignment, label set, foreign off statement, 4, var for binding in expression, statement, let key result be foreign, OFED evaluation, expression, enumerate, return, foreign, off-board evaluation, for binding, statement, key result, enumerate, var binding, label set. NOTE undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and the formal parameter lists of some non-strict functions, see 10.211. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 20244307. For in off statement. 4. For declaration in expression, statement, let key result be foreign, OFED evaluation, bound names of for declaration, expression, enumerate, return, foreign, off-board evaluation.
These people don't know how to write in assembly.
For in off statement. 4. Left the expression of assignment.
Chatbot kind of gets it.
Foreign, OFED evaluation.
But there's rotate instructions. There's like, this can be broken down to like much less than
Statement, key result, iterate, assignment.
one. It could probably be down to 4. Maybe 4 or 5 instructions. I don't know. This branchless code compared to the branch code,
Set, for in off statement.
it's not really a fair comparison.
Let key result be foreign,
I think they just needed an excuse to say, this is why we're using branches.
for declaration, statement, key result.
It's because they're doing more instructions overall. And because most of the time, this branch isn't taken and it enters. So that's not really branches because it's bigger and because they wrote it bad.
408. Var for binding of assignment expression, statement, let key result be foreign, offensive.
Yeah, see, branchless is down to 4 instructions. 1, 2, 3, 4.
For binding, statement, key result.
But they got 6 for x86. They're not, I don't know.
Think iterate, return, foreign, off. Key result, iterate, lexical binding, loop.
Oh, this has nothing to do with branch prediction. Our takeaway is branch predictors in modern CPUs are very good in code size. Affect your performance more. Oh, there's, okay, I don't know.
Pause node, and iteration of kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let olden be the running execution context's lexical event. If uninitialized bound is not empty, then 8. ECMA International 2024 ABC D. Assert, uninitialized bound has no DUPLICATE entries. Let new env be new declarative int, olden, for each string name of uninitialized bound, do I perform. New env.create a mute binding, name, false. Set the running execution context's lexical event to new env. 3. Let xpref be completion, evaluation of xpra. Set the running execution context's lexical event to olden. Let xpra-value be get value. Xpref, if iteration a kind is enumerate, then if xpra-value is either undefined or null, then I return completion record, break.
Oh my god, this is so stupid.
Xpra-value, C let iterator be enumerate obs, George D let next method be.
They observed that pointer compression reduces the heap size to 43%.
The iterator.
That's because they're using 32-bit numbers instead of 64-bit numbers, and 32-bit numbers are half the size of a 64-bit number. They didn't compress anything. They just used a smaller amount of memory on purpose instead of using the full 64-bit, which means if anything, they can't use all the available memory because they're compressing it to a 32-bit number. That's so misleading.
Language value or an abrupt completion. It performs the following steps when called. If iterator can do.
None. Okay, I don't know.
Let V be undefined. Let the structure ing be is destructuring.
But it says here,
Structure ing is true in the kind. Conclusion: the journey to get here was no bed of roses, but it was worth our while. 300 plus commits later, V8 with pointer compression uses as much memory as if we were running a 32-bit application, while having the performance of a 64-bit one. Compression uses as much memory as if we were running a 32-bit application, while having the performance of a 64-bit one.
but they don't have the memory of a 64-bit application because they compressed it to have the memory address size of a 32-bit application. They literally just, oh my god, it's so dumb.
Google says this about v6 compression use.
Here's some ask chat about this.
Google says this about v6 compression uses as much memory as if we were running a 32-bit application, while having the performance of a 64-bit one. Is that true? Because they end up using only 32 bits of addressing via compression, meaning that they clamp the available memory address to something smaller than what is available on 64-bit.
Alright, let's see what chat says.
Κεφαλαίο ωμέγα.
Yes, you're on the right track. That quote from Google, likely referring to pointer compression, sometimes called compressed hoops, in JVMs or similar VMs, is essentially describing a memory optimization strategy that takes advantage of 64-bit hardware while reducing memory usage, like on a 32-bit system.
Huh, that's weird.
While reducing memory usage, like on a 32-bit system.
So they're really just saying, fuck 64-bit memory, you only need 32 bits of memory. Because they're
that takes advantage of 64-bit hardware while reducing memory usage, like on a 32-bit system. Reducing memory usage. 32-bit system.
that's not really an optimization, because you can't use more memory if you're limited to 32-bit address space, because they quote compressed it to use less memory by not using the full address. And I'm pretty sure they have to go to a pointer off like a base pointer to an array, which means there's an extra overhead for every access through an array, because the compiler, whatever, it's not going to give them a 32-bit address, a 64-bit. They're going to get a 64-bit address, and they have to add to it. So they have an extra step there every time, which is why in their branchless code, they're adding only when true or false. Or whatever. This branchless code. So they must be adding to some base to get it to an offset of an array. And that's why the branch code is faster, because they're testing. And then most of the time, it's going to be adding. So since the branch isn't always taken, it's going to do this work in the pipeline, and it's going to be like, technically, I guess, completed before the branch has to be taken, so they get the benefit of prefetching or whatever. But it's not really prefetched until the code enters to be executed the first time, because it's not physically possible to prefetch something without fetching it first once. So I don't know, so that kind of makes sense now. This branchless code sucks.
The core idea, pointer compression on 64-bit systems. Memory pointers are 64 bits, 8 bytes. But most applications don't use anywhere near the full 2 bytes, 16 exabytes, or address space. Realistically, many large-scale apps might only need tens of gigabytes or even a few hundred. So, instead of storing full 64-bit pointers, we can
My JavaScript engine and it'll support however much RAM or paging is on the hardware. I'm not gonna limit it to 32 bits or whatever. I don't think they technically limit it. I think they can have 64-bit address too, but they load it up into 32-bit, or they access it as 64, and then something to store it as 32-bit.
Store 32-bit compressed pointers, offsets. Use a base address or known alignment to reconstruct the full 64-bit address. Get the benefits of 64-bit performance, more registers, more general-purpose computing power. Save memory like we're using 32-bit pointers.
Even though they pass around a 32-bit value, they still have to expand it to the 64-bit value at some point. I don't know, it makes no sense.
Why this works? If memory is aligned, e.g., 8-byte aligned, the lower 3 bits of pointers are always 0. If the heap is limited to 4 GB or 32 GB, we only need 32 bits or fewer to address within that heap. Pointers become offsets from a base, often scaled or shifted.
Oh, it's because the heap is limited. That's maybe why they do it. So they don't want to deal with multiple 4 GB allocations. So they make like one 4 GB allocation and then have it store other 4 GB allocations, I guess. I'm not sure.
This technique is common in JVMs, hotspot with compressed hoops, JavaScript engines, like V8 in Chrome, some game engines or memory-constrained allocators.
Why do they call it compressed oops?
So to answer your question, yes, they clamp or restrict the heap or addressable space to a smaller range, e.g., 32 GB, and use compressed 32-bit pointers to address memory relative to a base or with known patterns. The OS still uses 64-bit addresses underneath, but the application sees a compact, optimized VIEW. Would you like a diagram of how compressed? So to answer your question, yes, they clamp or
That's literally what I said. Why is it keep repeating?
restrict the heap or addressable space to. So to
Oh my god, it's stuck.
they clamp or restrict the.
I think it's done repeating. Why didn't they just say this in the first place? So to answer your question, why didn't they just say this? Why'd they have to go through all this? I literally explained exactly what chatbot finally got to the point of saying. Why do they have to add all this misleading bullshit, propaganda stuff, and then say, so to answer your question, I literally answered my own question that I asked it off its biased information before it got to here. Like I talked about, it has a memory access pattern relative to base or known patterns. It's still 64-bit underneath. It sees the compact. Like I literally said, I literally said all this stuff as I was reading through here, just like make my little comments, and then they finally answer here because I'm like, this stuff is kind of misleading how they're wording this, and then at the very end they say all this misleading shit, and then they actually answer it. So they like plant a biased seed of information up here to kind of like make you not think and make it down to here. I guess, did not expect you to read the whole thing. Or when you get down to here, you're like tired of thinking, and you're like, well, I guess everything must be true. I don't know. Chatbot sucks. I should try to focus. I think I like missed what I've even can talk about in the first place. I'm gonna stop getting distracted, I think. But this here, they show the branch code when I set the bit to indicate if it's an array or if it's a hash map. I'm going to put the access when it's an array right here. So it'll only take the jump like this when it's a hash map. So the array, when it runs the code, it'll get the benefit of the branch predictor. That'll be prefetch and stuff too. And compute or whatever. Even if the pipeline's wasted, it's a small computation. So when I set a bit, I think I'm just going to do this now that I'm thinking about it. I'm going to use a bit of the bottom 3 bits because I have extra bit now to indicate when it's an array or a hash map. So when it's an array, if I set up the code right and I put inside the if true case where it falls through, I'll have it access a normal array access with an offset. Otherwise I'll take the branch here and it'll be a little bit slower, but it doesn't matter because hash map is a hash map. What I want to do is preserve the speed of when it's a an array access. Like here, whatever. I don't want to zoom. Because when accessing an array, it's going to be a lot faster to like sort as an array when it's an array. If the index is always accumulated. And I don't have the overhead then of any extra base offset because I'm using 64-bit addressing, no pointer compression like they do. So it'll be like just a normal 64-bit access unless it's a hash map. Then it's going to be a little bit slower anyways. So I'll put that in the else case of the branch prediction. So I'm like making my decision based off, well, I don't know. I'm just thinking and talking at the same time. I'm trying to not be totally boring. It's pretty boring. I should get back to work. Just like different topics all at the same time. Making decisions based off things that come up, like branch speed tests and stuff, to just like, oh, I'll decide on this then. That's how it works. This is real-time programming. It's no tutorial. Just how it is. This here is a tutorial. It's a shitty tutorial that has memory leaks. It literally says memory leaks in it. By literally, I mean it physically says that in the documentation.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations.
Why is it flipping the page? What the heck? Ah, it's so annoying. Anyways, I'll just try to highlight it again, I guess. I don't know how it did that. I don't know how to undo it. I can't zoom in. Oh, but I can. Well, that's just blurry. I gotta like highlight top to bottom. At least that worked. So anyways. As they physically say in this documentation, literally, not even metaphorically, they straight up say that their engine, they don't know how to cook, they got a bunch of ingredients, it's 800 pages. It's 800 pages of documentation, a whole lot of recipes. Some of it doesn't work, and they admit this with some of the things by saying this.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations.
So say, what is this? A magnifier? And a magnifier? What the fuck is going on? Okay, whatever. I can't zoom. Fuck. God damn it. I'll just have to read it.
Could leak memory resources in implementations.
Why is it not highlighted when I zoom in with the magnifier? I think I'm gonna take a break. Things are kind of getting out of hand and I have no focus. I can't concentrate for shit. I think I have a memory leak in my implementation. This is annoying. How the fuck do I get rid of this magnifier? Why is it purple? Oh, it's the side. I hit escape, didn't escape. I'll be back, I guess. I'll try to see how to read this. I don't know what the fuck. This is so confusing. God damn it. Oh wait, it worked. It worked. I hit escape and it worked this time.
The abstract.
I'll BRB.
An object or undefined. P, a property key. Extensible, a boolean. Desk, a property descriptor. And current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility, and current property current while upholding invariance. When such application is possible and though is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert is property key, P is true. If current is undefined, then A. If extensible is false, return false. B. If O is undefined, return true. C. If a successor desk is true, then I create a known accessor property named P of object O whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. D. Else, I create a known data property named P of object O whose and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. E. Return true. Assert, current is a fully populated property descriptor. If desk does not have any fields, return true. If current is false, then 70 ECMA International 2024 ABC. If desk has a field in desk is true, return false. If desk has an field in desk is not current, return false. If as generic descriptor, desk, is false and a successor desk, is not a successor current, return false. D. If a successor current, is true, then I. If desk has a field in semi-value, desk, current, is false, return false. 2. If desk has a field in semi-value, desk, current, is false, return false. Else if current is false, then I. If desk has a field in desk is true, return false. 2. If desk has a field in semi-value, desk, current, is false, return false. If O is not undefined, then A. If his data descriptor, current, is true and his successor desk, is true, then I. If desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk, if desk has that field, or to the attribute's default value otherwise. B. Else if a successor current, is true and his data descriptor, desk, is true, then I. If desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. See else, I. For each field of desk, set the corresponding attribute of the property named P of object O to the value of the field. 7. Return true. 017 P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return ordinary has property O. P. 017 ordinary has property O. P. The abstract operation ordinary has property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let HSON be O, P. If HSON is not undefined, return true. Let parent be O. If parent is not null, then return parent. P. 5. Return false. 018 P. Receiver. The internal method of an ordinary object O takes arguments P, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called. Return ordinary get O, P. Receiver ECMA International 2024171 10181 ordinary get O, P. Receiver. The abstract operation ordinary get takes arguments O, an object, P, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then let parent be O. B. If parent is null, return undefined. C. Return parent. P. Receiver. If his data descriptor, desk, is true, return desk. Assert, a successor desk, is true. Let getter be desk. If getter is undefined, return undefined. Return, call, getter, receiver 019, PV receiver. The internal method of an ordinary object takes arguments P, a property key, V, an ECMAScript language value, and REC, EVA, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return, ordinary set O, P, V, receiver, 10191 ordinary set O, P, V, receiver. The abstract operation ordinary set takes arguments O, an object, P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let owndisk be O, P, return, ordinary set and one descriptor O, P, V, receiver, owndisk 0192 ordinary set and one descriptor O, P, V, receiver, owndisk. The abstract operation ordinary set and one descriptor takes arguments O, an object, P, a property key, V, an ECMAScript language value, receiver, an ECMAScript language value, and owndisk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If owndisk is undefined, then I let parent be O. B. If parent is not null, then I return parent P, V, receiver. C. Else, I set owndisk to the property descriptor, undefined, true, true, true. If is data descriptor, owndisk, is true, then 72 ECMA International 2024 A B C D E. If owndisk is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver P. If existing descriptor is not undefined, then I. If a successor adapter, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor, V, IV. Return, receiver, P, value desk. Else, I assert, receiver does not currently have a property P. 2. Return, create a data property, receiver, P, V, assert, a successor adapter, owndisk, is true. Let setter be owndisk. If setter is undefined, return false. Perform, call, setter, receiver, V, return true. 0110, P. The internal method of an ordinary object takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return, ordinary delete O, P, 101101 ordinary delete O, P. The abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, return true. If desk is true, then remove the own property with name P from O. Be return true. Return false. 11. The internal method of an ordinary object takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary and properties, O. 101111 ordinary and properties, O. The abstract operation ordinary and properties takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do append P to keys. 5. Return keys. 0 first 1 2 ordinary object crib, proto, addition external. The abstract operation ordinary object crib takes argument proto, an object or null, and optional argument addition external, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Addition external contains the names of additional internal slots. ECMA International 2024173 that must be defined as part of the object, beyond and. If addition external is not provided, a new empty list is used. It performs the following steps when called. Let internal slots int be. If addition external is present, set internal slots int to the list concatenation of internal slots int, and addition external. Let O be make passic object internal slots int, set O to proto, return no, 0113 ordinary create from constructor, intrinsic default proto, internalslotslist. The abstract operation ordinary create from takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots int, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for internal slots and contains the names of additional internal slots that must be defined as part of the object. If internal slots int is not provided, a new empty list is used. It performs the following steps when called. Assert intrinsic default proto is the specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be get prototype fructor, constructor intrinsic default proto. If internal slots int is present, let slots list be internal slots int, else, let slots list be a new empty list. Return ordinary object crib, proto, slots list, 0114 get prototype fructor, constructor intrinsic default proto. The abstract operation get prototype fructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object, or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert intrinsic default proto is the specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be get constructor prototype. If proto is not an object, then a let realm be get function realm constructor be set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note: although ordinary object crib does little more than call make passic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make passic object directly. 174 ECMA International 2024. NOTE: if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. 10 first 1.5 require internal, O internal slot. The abstract operation require internal takes arguments O, an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object, and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript function objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of that code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript function object may be either strict mode code 1122 or non-strict code. An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to and, ECMAScript function objects also have the internal slots listed in Table 30. Table 30 Internal slots of ECMAScript function objects. Internal slot type, description, environment, and environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment record or null. The private environment record for private names that the function was closed over, null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node, the root parse node of the source text that defines the function's formal parameter list. ECMAScript. A parse node, the root parse node of the source text that defines the function's body. Constructor kind, base or derived, whether or not the function is a derived class constructor. Realm. A realm record, the realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module, a script record or a module record, the script or module in which the function was created. This mode, lexical, strict, or global, defines how these references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024. 75. Table 30, internal slots of ECMAScript function objects. Continued. Internal slot type, description, strict, a boolean, true if this is a strict function, false if this is a non-strict function. Home object, an object, if the function uses super, this is the object whose provides the object where super property lookups begin. Source text, a sequence of Unicode code points, the source text that defines the function. Fields, a list of class field definition records, if the function is a class. This is a list of records representing the non-static fields and corresponding initializers of the class. Private methods, a list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name, a string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named derivation of the field, empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 021, this arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value, or a completion. It performs the following steps when let caller context be the running execution context.
Arguing with chatbot. Well, basically just agreeing with chatbot. Because why argue in the first place? It's not intelligent. It's arguing with pre-programmed training data. Predefined answers to specified questions. Doing that, whatever. And looking at assembly language kind of made me feel alive, because programming in C language and JavaScript is really boring. Makes me feel dead. It's like extremely boring. So I think I have like a little bit more energy, so I might try to get this loop running and speed test today, not wait till tomorrow. Or I'll wait. I don't know. I don't have a burst of energy yet. If I have one. I don't know, today I feel a little bit off. So I'm gonna try to focus whatever. And like, at least convert the rest of the loop if I don't run it or whatever.
Context be a new ECMAScript code execution context. Set the function of Kali context to f, let Kali realm be f, Set the realm of Kali context to Kali realm. Set the script or module of Kali context to F. Let localin be new function in VI environment. F. New target. Set the lexical environment of Kali context to localin. Set the variable environment of Kali context to localin 0. Set the private environment of Kali context to F1. If caller context is not already suspended, suspend caller context. 2. Push Kali context onto the execution context stack. Kali context is now the running execution context. 3. Note, any exception objects produced after this point are associated with Kali realm. 4. Return Kali context 0212 ordinary carbon this. F Kali context this argument. The abstract operation ordinary carbon S takes arguments F, an ECMAScript function object, Kali context, an execution context, and this argument, an ECMAScript language, value, and returns unused. It performs the following steps when called. Let this mode be F. If this mode is lexical, return unused. Let Kali realm be F. Let localin be the lexical environment of Kali context. If this mode is strict, then let this value be this argument. 6. Else, if this argument is either undefined or null, then let global env be Kali realm. 2. Assert, global env is a global environment record. 3. Let this value be global env. B else, let this value be TOBject, this argument. 2. Note, TOBject produces wrapper objects using Kali realm. Assert, localin is a function environment record. Assert, the next step never returns in abrupt completion because localin is not initialized. Perform, localin.bind this value 0. Return unused. 0213 runtime semantics, evaluate a body. The syntax-directed operation evaluate a body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value, or an abrupt completion. It is defined piecewise over the following productions: function body, function state list, return, evaluate to function body with arguments function object and arguments list, concise body, expression body, return, evaluate a concise body of concise body with arguments function object and arguments list. ECMA International 20241177 generatable body, function body, return, evaluate a gener body of generatable body with arguments function object and arguments list. Async generator body, function body, return, evaluate async upon gen body of async generator body with arguments function object and arguments list. Async function body, return, evaluate async budding body of async function body with arguments function object and arguments list. Async concise body, expression body, return, evaluate async body of async concise body with arguments function object and arguments list. Initializer, assignment expression, assert, arguments list is empty, assert, function object is not empty. If a synonymous assignment expression is true, then let value be named a delineation of initializer with argument function object. Else, let arrays be evaluation of assignment expression. B let value be get value arrays. Return completion record, return, value, empty, class static block body, class static block state lost, assert, arguments list is empty, return, evaluate static block body of class static block body with argument function object. 0214 ordinary eval F argument ends list. The abstract operation ordinary eval takes arguments F, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value, or an abrupt completion. It performs the following steps when called. Return, evaluate a body of F with arguments F in arguments list. 1022, arguments list new target. The internal method of an ECMAScript function object F takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F. If kind is base, then let this argument be ordinary create from cons. New target, %object.pro, to type %. 4. let curly context be prepare for ordinary call F. New target 178 ECMA International 2024. Note, even though field initializers constitute a function boundary, calling function declaration does not have any observable effect and so is omitted. 5. Assert curly context is now the running execution context. If kind is base, then upper form ordinary or parenthesis F curly context.
YouTube, whatever. I have a playlist. When you set a thumbnail to the playlist, you always have to set the thumbnail because there's no option to turn off if you want a thumbnail that's preset, or if you want the top video to be the thumbnail for that playlist.
List. Remove.
There used to be an option, I swear there was a button, but it's not there anymore.
Context.
I don't know if they did that on purpose, or if they forgot it and nobody noticed. But there's no button to turn off. So like, if I want the thumbnail to match what's in the playlist on YouTube, after I set a picture, I always have to set a picture to whatever the thumbnail is, because it's not in sync. There's no option to pick, just do whatever the top video is as a thumbnail. And then when you Google for a music video to get the thumbnail, it doesn't always come up. So this is how you get the thumbnail of a music video. I have to stop wasting time.
Non-lexical this. Env. An environment
I'll stop wasting time after this.
record or null and
Probably not. But I'll make up for it when I can hyper focus, and I'll get a whole bunch done to make up for all the times I didn't get anything done. It's how ADHD works. And I think they're calling autism ADHD now, like ADHD, because autism has a bad rep. People use autism or autistic as like a negative label. So I think they're trying to like medical whatever. They're trying to tie together autism, ADHD, because everyone's like, I got a fidget spinner. I have ADHD. Everybody wants ADHD. If you're not diagnosed medically by a doctor, you don't have ADHD. ADHD is a mental illness. Why the fuck are people running around saying, I have ADHD when they don't? They're literally telling people that they have a mental illness when they don't. They have a fidget spinner for a mental illness that they don't have.
3. Return F. ECMA International 2024179 1024 add restricteds F realm. The abstract operation object and realm record and returns unused.
Okay, it's a mental health condition.
Initialized. Let throw a B realm.
I guess they won't call it an illness,
Caller. Property descriptor.
but they can get really close to calling it. It's just a disorder then.
Percent throw type 0%.
Yeah, I don't know. Whatever. People make no sense. I think that's why they want to tie together ADHD and autism as ADHD, because autism has like a negative rep. People run around with fidget spinners.
Right of left ripe. Prototype. The abstract operation make constructor takes argument F, an ECMAScript function object, or a built-in function object, and optional arguments right of left ripe.
people run around with these fidget spinners, whatever.
Used. It converts f into a constructor.
And they got like, or they got like a squishy ball or some stupid thing. And they have like the privilege to be like, I got ADHD. Like, fuck you, don't. Fuck you. It's so annoying. Okay, so my original topic was music video thumbnails on YouTube. I gotta stay on topic and then I get to coding.
Property throw, prototype, constructor, property descriptor, f, writable, writable pipe, false, true, perform, define property throw, f.
Actually, I'm just gonna program. I'm not gonna look up YouTube thumbnails or how to get a thumbnail. I'm just gonna try to focus. I need some water.
Function object and returns unused. It performs the following steps when called. Assert f is false, set f to true, return unused. 0 to 7 make method f, home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused. 0 second 8 define a method property, home object, key, closure, enumerable. The abstract operation define a method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert, home object is an ordinary, extensible object. If key is a private name, then a return private element, key, method, closure. 3. Else, a let desk be the property descriptor, closure. True, enumerable, true, be perform, define property throw, home object, key, desk. See note, define property throw only returns an abrupt completion when attempting to define a class static method whose key is prototype. D return unused. 0 second 9 set function name, f, name, prefix. The abstract operation set function name takes arguments f, a function object, and name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert f is an extensible object that does not have a name, own property. If name is a symbol, then a let description be name's value. B if description is undefined, set name to the empty string. C else, set name to the string concatenation or description, and else if name is a private name, then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix, the code unit 0 times 20, space, and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property throw, f, name, property descriptor, name, false, enumerable, false, true, return unused. ECMA International 2024181, 10 second 10 set function length, f length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int a, j or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert f is an extensible object that does not have a length own property. Perform. Define property throw, f, length, property descriptor, length, false, enumerable, false, true, return unused. 0 second 11 function declaration, func arguments list. The abstract operation function declaration takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. NOTE1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of function declaration. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter actions be contains accretion of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let L executable names be the lexical declares of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do a if D is neither a variable declaration, nor a forbinding nor a binding identifier, then I assert D is either a function declaration, a generator declaration, an async declaration, or an async generation. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note: if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object be true. 6. If func is lexical, then note: arrow functions never have an arguments object. B. Set arguments object to false. 7. Else if parameter names contains arguments, then A. Set arguments object to false. 82. ECMA International 2024. 18. Else if has parameter actions is false, then if function names contains arguments, or lexical names contains arguments, then I. Set arguments object to false. 9. If strict is true or has parameter actions is false, then note: only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B. Let env be the lexical event of context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B. Let calenv be the lexical event of context. C. Let env be new declarative event. Calenv. D. Assert the variable environment of context is calenv. E. Set the lexical event of context to env. 1. For each string param name of parameter names, do a let already declared B. The env has binding, param name. B. Note: early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. C. If already declared is false, then I perform the env.create a mute binding, param name, false. 2. If has duplicates is true, then perform the env.initialize binding, param name, undefined. 22. If arguments object is true, then I. If strict is true or simple parameter list is false, then I let out be create on map suggest object, arguments list. B. Else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let out be create mapped argument, func, formals, arguments list, env. See if strict is true, then I perform the env.create a binding, arguments, false. 2. Note: in strict T-mode code early errors prevent attempting to assign to this binding, so its mutability is not observable. D. Else I perform the env.create a binding, arguments, false. E. Perform the env.initialize binding, arguments, F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, let parameter bindings be parameter names. 4. Let iterator record be create a list record arguments list. 5. If has duplicates is true, then a perform iterationization of formals with arguments iterator record and undefined. 26. Else, a perform iterationization of formals with arguments iterator record and env. 27. If has parameter actions is false, then a not only a single environment record is needed for the parameters in top level vars. B. Let instantiated var names be a copy of the list parameter bindings. C for each element n of var names. Do I. If instantiated var names does not contain, then append n2 instantiated var names. Perform env.createMute binding n. False. Perform env.initialize binding n. Undefined. D let var be env. 28. Else. A note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var be no declarative int. Env. C set the variable environment of context to var. D. Let instantiated var names be a new empty list. E for each element n of var names. Do I. If instantiated var names does not contain, then ECMA International 2024183-1. Append n2 instantiated var names. Perform var.createMute binding n. False. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined. 4. Else a let initial value be the env.get binding value n. False. Perform var.initialize binding n. Initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Not, an xb321 adds additional steps at this point. 0. If strict is false, then a let lexenv be no declarative int. Varenv. B not, non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexenv be varenv. 2. Set the lexical envint of context to lexenv. 3. Let lex declarations be the declarations co-declarations of code. 4. For each element d of lex declarations, do a note, a lexically declared name cannot be the same as a function, generate a declaration, formal parameter, or a var name. Lexically declared num s are only instantiated here but not initialized. B for each element ddn of the bound names of d, do I. If a constant declaration of d is true, then perform lexenv.createMute binding ddn true. 2. Else perform lexenv.createMute binding dn false. 5. Let private env be the private environment of context. 6. For each pass node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantia function object of f with arguments lexenv and private env. C perform varenv.set mutable binding fn fo false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2235. The initial value of a built-in function object's internal slot is %function.pro, to type %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 10.3.1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 10.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. NOTE2B32 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015-84. Copyright sign, ECMA International 2024. 1031. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called: return, built-in caller construct, f, this arguments list, undefined. 1032, arguments list new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in caller construct, f, uninitialized, arguments list, new target. 1033 built-in caller construct, f this arguments list new target. The abstract operation built-in caller construct takes arguments f, a built-in function object, this argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, and new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called: let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let Kali context be a new execution context. Set the function of Kali context to f. Let Kali realm be f. Set the realm of Kali context to Kali realm. Set the script or module of Kali context to null. Perform any necessary implementation defined initialization of Kali context. Push Kali context onto the execution context stack. Kali context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f. If this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides that this value. Arguments list provides the named parameters. New target provides the new target value. 1. NOTE, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove Kali context from the execution context stack and restore caller context as the running execution context. 3. Return result 0. 4. Create built-in function behavior length name addition external realm prototype prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior, provided in this specification. Length, a non-negative integer or plus, name, a property key or a private name, and addition external, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string, and returns a function object. Addition external contains the names of additional internal slots that must NOTE when Kali context is removed from the execution context stack. It must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called: if realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots int be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots int the elements of addition external. Let func be a new built-in function object that, when call ed, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots int, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null. 0th. Performs set function length, func, length 1. If prefix is not present, then A performs set function name, func name. 12. Else A performs set function name, func name, prefix. 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 041 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable, it has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in Table 30. Instead they have the internal slots listed in Table 31. In addition to and Table 31, internal slots of bound function exotic objects, internal slot type description, bound get function, a callable object, the wrapped function object, bound this, an ECMAScript language value, the value that is always passed as the this value when calling the wrapped function, bound arguments, a list of ECMAScript language values, a list of values whose elements are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 10411 This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called: let target bf, let bound this bf, let bound args bf, let args be the list concatenation of bound args, and arguments list, return, call, target, bound this, args. 0412, arguments list new target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: let target bf, assert, is constructor, target, is true, let bound args bf, let args be the list concatenation of bound args and arguments list, if some value, f, new target, is true, set new target to target, return, construct, target, args, new target, 04 first 3 bound function create, target function bound this bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMAScript language value, and bound args, a list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called: let proto be target function, let internal slots int be the list concatenation o, and the internal slots listed in Table 31. Let George be make basic object internal slots int, set George to proto, set George as described in 10411. If is constructor, target function, is true, then a set George as described in 10412, set obj to target function, set obj to bound this, set obj to bound args. 0. Return George. 042 Array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C617. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index. Whenever a known property of an array is created or changed, other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own ECMA International 2024-187. Properties of an array is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0421 pdesk. The internal method of an array exotic object A takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then return array set length a desk, else if p is an array index, then a let length desk be ordinary pound property a length b assert is data descriptor length desk is true. C assert length desk is false. D let length be length desk. E assert length is a non-negative integral number. F let index be how int 32 p. G if index length and length desk is false, return false. H let succeeded b ordinary def noun e property a p desk. I if succeeded is false, return false. J if index length, then I set length desk to index plus 1 2. Set succeeded 2 ordinary def noun e property a length desk 3. Assert succeeded is true. K return true. Return ordinary def noun e property a p desk 0422 array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto, an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length greater than 232, first, throw a ranger or exception. If proto is not present, set proto to %array.pro, to type %. Let a be make basic object. Set a to proto. Set a as specified in 10.421. Perform ordinary def noun e property a length property descriptor length true false return a 04 second 3 RSPCS create original array length. The abstract operation RSPCS create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let isArray be isArray, original array. If isArray is false, return array create length. Let C be get original array constructor. If is constructor C is true, then 88 ECMA International 2024. Let this realm be the current realm record. B let realm be get function realm C. See if this realm and realm are the same realm record, then I if some value C realm is true. Set C to undefined. If C is an object, then a set C to get C 88 species. B if C is null, set C to undefined. If C is undefined, return array create length. If is constructor C is false, throw a type error exception. Return construct C length 04 second 4 array set length a desk. The abstract operation array set length takes arguments a, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary def noun e property a length desk. Let newlen desk be a copy of desk. Let newlen be how int 32 desk. Let numberlen be to number desk. If some value is 0, newlen numberlen is false, throw a ranger or exception. Set newlen desk to any WLEN. Let oldland s be ordinary pound property. A. Length. Assert is data descriptor. Oldland s is true. Assert oldland s is false. 0. Let oldland be oldland s. 1. If newland oldland, then a return. Ordinary def noun e property. A. Length. Newland-esque. 2. If oldland s is false, return false. 3. If newland-esque does not have a field or newland-esque is true, then a let new writable be true. 4. Else, a not setting the attribute to false is deferred in case any elements cannot be deleted. B. Let no writable be false. Set newland-esque to true. 5. Let succeeded be ordinary def noun e property. A. Length. Newland-esque. 6. If succeeded is false, return false. 7. For each own property key P of A such that P is an array index and how int 32, P, Newland, in descending numeric index order, do a let delete succeeded B. P, B. If delete succeeded is false, then I. Set Newland-esque to how int 32, P, plus 1, 2. If unwritable is false, set Newland-esque to false. 3. Perform ordinary def noun e property. A. Length. Newland-esque. IV. Return false. 8. If unwritable is false, then a set succeeded to ordinary def noun e property. A. Length. Property descriptor. False. B. Assert succeeded is true. 9. Return true. NOTE if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array.pro2 type methods that now are defined using RSPCS create. ECMA International 2024189. Note: in steps 3 and 4, if desk is an object then its valoof method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 043 String exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length, whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string crate. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot. 10.431, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary pound property S, P. If desk is not undefined, return desk. Return stringy town property S, P. 0432, P desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be stringy town property S, P. If string desk is not undefined, then a let extensible be S. B return is compatible pripter, extensible, desk, string desk, return. Ordinary def noun e property S, P, desk 0433. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O. Assert str is a string. Let lay be the length of str. For each integer I such that 0th lesser or equal to I less than li, in ascending order, do append toString I, 2 keys. For each own property key P of O such that P is an array index and 20 or infinity, P, li, in ascending numeric index order, do append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, to a append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do append P to keys. 9. Return keys 0434 string greet, value, prototype. The abstract operation string greet takes arguments value, a string, and prototype, an object, and return, ns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make passic object, set S to prototype, set S to value, set S as specified in 10431, set S as specified in 10432, set S as specified in 10433. Let length be the length of value. Perform. Define property throw S, length, property descriptor, length, false, enumerable, false, false, return S, 0435 string town property, SP. The abstract operation string town property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numbering, P. If index is undefined, return undefined. If i's integral number, index, is false, return undefined. If index is -0, return undefined. Let str be s. Assert, str is a string, let le be the length of str. If r, index, less than 0 or le lesser or equal to r, index, return undefined, 0. Let results to be the substring of str from r, index, to r, index, +1, 1. Return the property descriptor, results to, false, true, false, 044 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in createMap.argument. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object.pro2type.toString 2136 to identify them as such. Note1 while createOnMapSubject object is grouped into this clause. It creates an ordinary object, not an arguments exotic object. ECMA International 2024191 Note2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the funct. IN's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function and there is no dynamic linkage between the property values and the formal parameter values. Note3 The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note4 Ordinary arguments objects define a non-configurable accessor property named Cali, which throws a type error exception on access. The Cali property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note5 ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor 0441p. The internal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary town property, args p. If desk is undefined, return undefined. Let map be args. Let is map be harass-own property, map p. If is mapped is true, then a set desk 2. Get map p. 6. Return desk 0442 p desk. The internal method of an argument's exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is map be harass-own property, map p. Let new org desk is b desk. If is mapped is true and is data descriptor, desk, is true, then, if desk does not have a field, desk has a field, and desk is false, then, I. Set new org desk is to a copy of desk 2. Set new org desk is to. Get map p. Let allowed be ordinary noun e property, args p. Newer the desk. 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then a. If a success auditor desk is true, then I perform map p. B else I. If desk has a field, then assert the following set will succeed, since formal parameters mapped by arguments objects are always writable. Perform set map p. Desk false 2. If desk has a field and desk is false, then perform map p. 8. Return true 0443 p. Receiver. The internal method of an argument's exotic object args takes arguments p, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called. Let map be args. Let is map be harass-own property, map p. If is mapped is false, then return ordinary get args p. Receiver. 4. Else, assert map contains a formal parameter mapping for p. Be return get map p. 0444 pb receiver. The internal method of an argument's exotic object args takes arguments p, a property key, v, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If some value, args, receiver, is false, then a let is map be false, else a let map be args. B let is map be harass-own property, map p. If is mapped is true, then assert the following set will succeed, since formal parameters mapped by arguments objects are always writable. B perform set map p. V. False. Return ordinary set args p. V. Receiver 0445 p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args. Let is map be harass-own property, map p. Let result be ordinary let args p. If result is true and is mapped is true, then perform map p. 5. Return result. ECMA International 2024193 10446 create on map suggest object arguments list. The abstract operation create on map suggest object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let lib be the number of elements in arguments list. Let judge be ordinary object crib %object.pro to type %. Set judge to undefined. Perform define property throw judge length property descriptor li true enumerable false true. Let index be 0. Repeat while index less than li let val be arguments list index, b perform, created at earth row, George. ToString, index, val, c set index to index +1, perform, define property earth row, obj, 8 iter property descriptor, %array.pro, to type.values %, true, false, true, perform, define property earth row, George. Cali, property descriptor, %row type error %row type error false, false, return George. 0447 create map PROLOGUE, func formals arguments list env. The abstract operation create map PROLOGUE takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert, formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let lib be the number of elements in arguments list. Let George be make basic object. Set George as specified in 10441. Set George as specified in 10442. Set George as specified in 10443. Set George as specified in 10444. Set George as specified in 10445. Set George to %object.pro, to type %0. Let map be ordinary object crib, null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat, while index less than li, let val be arguments list, index, b perform, created at earth row, George. ToString, index, val, c set index to index +1, 6. Perform, define property earth row, George. Length, property descriptor, li, true, false, true, 7. Let mapped names be a new empty list, 8. Set index to number parameters, first, 9. Repeat, while index 0. 94. ECMA International 2024. A B. C. Let name be parameter names, index. If mapped names does not contain name, then I append name to mapped names 2. If index less than li, then let G be maker getter, name, env. Let P be maker setter, name, env. Perform, map. ToString, index, property descriptor, P, get, G, false, true, set index to index, 1, 20. Perform, define property earth row, obj, 8 iter property descriptor, %array.pro, to type.values true, false, true, 1. Perform, define property earth row, George. Cali, property descriptor, func, true, false, true, 2. Return George. 0447 maker getter, name, env. The abstract operation maker getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name in env. It performs the following steps when called. Let getterClosure be a new abstract closure with no parameters that captures name in env, and performs the following steps when called. A return env.getBinding value, name, false. Let getter be create function, getterClosure, 0. Note, getter is never directly accessible to ECMAScript code. Return getter, 0447 to make setter, name, env. The abstract operation make setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name in env. It performs the following steps when called. Let setterClosure be a new abstract closure with parameters, value, that captures name in env and performs the following steps when called. A return env.setMutable binding, name, value, false. Let setter be create function, setterClosure, 1. Note, setter is never directly accessible to ECMAScript code. Return setter, 045 typeheader A exotic objects. A typeheader A is an exotic object that performs special handling of integer index property keys. Typeheader A's have the same internal slots as ordinary objects and additionally, array length, and internal slots. An object is a type either A if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by type header create 0451 p. The internal method of a type either AO takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numerous index be canonical numbering p. B if numerous index is not undefined, then I let value be type header agent element o. Numerous index 2. If value is undefined, return undefined. 3. Return the property descriptor value true, true, true. Return ordinary pound property o. P. ECMA International 202419510452 p. The internal method of a type either AO takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numerous index be canonical numbering p. B if numerous index is not undefined, return as valid integer index o. N numerous index, return ordinary has property o. P 0453 p desk. The internal method of a type either AO takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numerous index be canonical numbering p. B if numerous index is not undefined, then I if is valid integer index o. Numerous index is false, return false. 2. If desk has a field in desk is false, return false. 3. If desk has a field in desk is false, return false. 5. If a success auditor desk is true, return false. V if desk has a field in desk is false, return false. V if desk has a field perform type array settlement o. Numerous index desk. 7. Return true, return ordinary noun property o. P desk 0454 p receiver. The internal method of a type either AO takes arguments p, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called. If p is a string, then a let numerous index be canonical numbering p. B if numerous index is not undefined, then I return type header agent element o. Numerous index 2. Return.
I don't know if I set up my engine to support
Of a type either AO takes arguments p, a property
a list of an operation row, like operations row.
either a normal completion containing a boolean or following steps when
Like parentheses with var plus var plus var, or var minus var plus var minus var, or whatever.
value o. Receiver is true. Then perform
I think you need to like break it up.
integer index o. Numerous index is true. Return ordinary p. V. ECMA International 2024 10.
I don't know, it's like I have to like run it and check.
If numerous index is not undefined, then I if is valid integer index o. Numerous index is false, return true, else return false. 2. Return ordinary delete o. P 0457. The internal method of a type either AO takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let code be make it type error through with technicode o. Sexity. Let keys be a new empty list. If he returns code is false, then a let length be type either a length code be for each integer I such that 0th lesser or equal to I less than length In ascending order, do I append toString
And then there's like
P of O such that P is a string and P
some optimizations or whatever.
do I append
I'm gonna have to add later.
in ascending chronology.
Like if you like splitting up
Peter A with buffer
editions into like 2 separate editions, add it to one final edition.
attached byte length
Right now it just goes in order by sequence.
buffer is a growth
I have a couple things that do that, but not with list of operations in a row. So I gotta add that and a couple other tiny things that'll probably take forever to add. Well, I don't need it. Maybe an optimization, so I'd have to like, I'll wait till I like support the standard, then I'll bother with optimizing.
detached field name value meaning object a type either A. The type either A whose buffer's byte length is loaded. Head buffer tooling a non-negative integer or detached the byte length of the objects when the record was created. Copyright sign ECMA International 2024197-3 else a let byte length the array buffer bitoling buffer order return the type either A with buffer witness record George byte length 045010 type array create prototype. The abstract operation type array create takes argument prototype, an object, and returns a type either A. It is used to specify the creation of new type either A's. It performs the following steps when called. Let internal slots int b. Let a be make basic object internal slots int. Set a as specified in 10451. Set a as specified in 10452. Set a as specified in 10453. Set a as specified in 10454. Set a as specified in 10455. Set a as specified in 10456. Set a as specified in 10457. 0. Set a to prototype 1. Return a 04511 type header byteling code. The abstract operation type header byteling takes argument code, a type either A with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If returns code is true, return 0. Let length be type either A length code. If length equals 0, return 0. Let O be code. If O is not auto, return O. Let element size be type element size O. Return length element size 04512 type either A length code. The abstract operation type either A length takes argument code, a type either A with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert returns code is false. Let O be code. If O is not auto, return O. Assert disfixed for eBay O is false. Let byte offset be O. Let element size be type element size O. Let byte length be code. Assert byte length is not detached. Return floor byte length byte offset element size 04513 returns code. The abstract operation returns takes argument code, a type either A with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be code. Let buffer byte length be code. 98. ECMA International 2024. 3. Assert is detached buffer O is true if and only if buffer byte length is detached. If a buffer byte length is detached, return true. Let byte offset start be O. If O is a UTO, then A. Let byte offset n be buffer byte length, else a let element size be type element size O. B. Let byte offset n be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. NOTE 0. Length type either A's are not considered out of bounds. 0. Return false. 04514 is valid integer index O. Index. The abstract operation is valid integer index takes arguments so, a type delay, and index, a number, and returns a boolean. It performs the following steps when called. If is detach buffer, O, is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let code be make type delay with method. OTE. Bounds checking is not a synchronizing operation when O's backing buffer is a
I'm gonna have to run things in like chunks or whatever, and then check for if it breaks, and then rewrite it to account for like the order of operations.
takes argument so.
That's like the most disappointing burp ever. And the burp is like a half burp. And I still have to burp, it's not coming up to burp. I don't know, anyways. This is boring, really boring. I'm gonna like convert the rest of this, but then I'll have to like test it in chunks. Because some of the order of operations, whatever,
Completion containing unused or a throw.
they have to be in a certain order because of how I have macros set up. And I'm not adding any new macros or adjusting anything until I get to
Then, a let offset BO, B let element size B type radar element size, O.
until I get to the standard.
Index, times element size.
And even then I'm not gonna change anything until I read something that has to be changed, then I'll add it.
X and buffer, element value, true.
Because at some point, the stuff that I would add now or whatever is gonna show up in here.
Buff out of bounds, O.
So I'm gonna like convert over what matches currently. And I have to add like a couple extra steps for my engine because it doesn't do it exactly the same way as it looks.
This abstract operation convenience
So I don't know, I'm gonna do that then.
and called. If O has an internal slot, then a let view record B make a dative with witness written witness record O. Sexity B return is V what off bounds, view record. Let code B make it type delay with written off it O. Sexity return EC pedar ons, code 046 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module, C1623. There is a one-to-one correspondence between the string key-own properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its getProtot, EPIF, and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33, internal slots of module namespace exotic objects. Internal slot type description module record. The module record whose exports this namespace exports a list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array.pro, totype.sort %, using undefined as comparefn 10461. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a type header A, or to a type header A, which is backed by a detached array buffer 10462 v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Let a mutable prototype O v0463. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0464. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0465 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary town property O, p, let exports be O. If exports does not contain p, return undefined. Let value be O, p, O. Return property descriptor, value, true, true, false. 0466, pdesk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary noun e property O, p, desk. Let current be O, p. If current is undefined, return false. If desk has a field in desk is true, return false. If desk has a field in desk is false, return false. If a successor auditor, desk, is true, return false. If desk has a field in desk is false, return false. If desk has a field, return some value, desk, current. Return true. 0467 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a symbol, return ordinary has property O, p. Let exports be O. If exports contains p, return true, return false. ECMA International 20242011 10468, p receiver. The internal method of a module namespace exotic object O takes arguments p, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value, or a throw completion. It performs the following steps when called. If p is a symbol, then a return ordinary get O, p, receiver, let exports be O. If exports does not contain p, return undefined. Let MBO, let binding bm.resolve export p, assert, binding is a resolved binding record. Let target module be binding. Assert, target module is not undefined. If binding is namespace, then a. Return get module namespace, target module 0. Let target inv be target module 1. If target inv is empty, throw a reference error exception 2. Return target inv.get binding value, binding, true. 0469, PV receiver. The internal method of a module namespace exotic object takes arguments p, a property key, v, an ECMAScript language value, and receiver, an ECMAScript language value, and returns a normal completion containing false. It performs the following steps when called. Return false. 10.
I think it'll build. I don't think it'll work. Or it'll work, but
A normal completion containing a boolean.
it'll work, but some of the syntax, whatever's screwed up, so it'll skip over some of the things that don't match the pattern. So I check little blocks at a time to make sure they're all right. So I'll just build it all first and see if it builds. and go like build chunks at a time. I gotta make a parser. This takes way too long to like do by hand and like remember how to like set things up or whatever to match the pattern of how things have to be set up, basically. Be like super generic way of saying it without being too specific or whatever.
The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic.
Build, see what happens.
New module namespace exotic objects. It performs the following steps when called. Assert, module is empty. Let internal slots int be the internal slots listed in table 33. Let mb make basic object
and then wait a minute and 20 seconds to build. That's how long it takes to build. It takes so long to build. Come on, build. Build.
Do type dot.
Such a long time to freaking wait for it to compile. Build.
Properties of m corresponding to the def. 047 Immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not.
Testing. Right side. Left side. Right. Microphone thingy. Left microphone thingy. Stereo. Audio. It's stereo. Oh, this is so long to build. Just built already. No. So I guess I missed a couple places. That's cool.
V. The abstract operation let immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O, if some value V, current, is true. Return true. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, or a handler object may be used to augment the implement at and for one or more of the proxy object's internal methods. Every proxy object also has an internal NOTE. Unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object.pro to type %n by host environments, and in host environments, the relevant objects are potentially exotic in other ways, and thus need their own dedicated creation operation. ECMA International 2024203, slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object of its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34, proxy handler methods, internal method, handler method, jprototypef, set prototypef, is extensible, prevent extensions, getown property, define defining property, has get, set, delete, property, unproperties, unkeys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. Then internal slots of a proxy object are always initialized when the object is created and typically may not be modified.
And then build it again. It should build this time.
Proxy is revoked. Its internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6173. Some of the internal method invariants defined in 6173 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, a sumo is an ECMAScript proxy object, P is a property key value, V is any ECMAScript language value, and desc is a property descriptor. Record 4. Copyright sign, ECMA International 2024 5.1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called: perform, avalate and on-revoke C, O, let target be O, let handler be O, assert, handler is an object, let trap be, get method, handler, JPrototype if trap is undefined, then return, target. Let handler proto be, call, trap, handler, target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be, is extensible, target 0. If extensible target is true, return handler proto 1. Let target proto be, target 2. If some value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 052, V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called: perform, avalate and on-revoke C, O, let target be O, let handler be O, assert, handler is an object, let trap be, get method, handler, set prototype if trap is undefined, then return, target, V, let boolean trap result be to boolean, call, trap, handler, target, V, if boolean trap result is false, return false, let extensible target be, is extensible, target 0. If extensible target is true, return true 1. Let target proto be, target 2. If some value, V, target proto, is false, throw a type error exception 3. Return true. NOT for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. NOT for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of JPrototype. Applied to target object, ECMA International 2024-205-1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs
And builds. I'll include more code and see what spot it's gonna suck at. This is like so much fun. This is so exciting. This is great. I love sitting here, like doing little pieces of code at a time and then waiting a minute and a half for the compiler to build, because it's a modern compiler and it sucks. It sucks. Microsoft Visual Studio compiler sucks.
steps when called.
So I'm like, move some code out and try it again and try to find where it's getting stuck.
Object. Let trap be.
I could check where it's saying the error messages are.
Trap is undefined. Then return.
When it says there's an error in the compiler, like when it says error down here. But half the time, it's not useful. And 50% odds are terrible. So I'm not going to waste clicking on the error message half the time, because half the time it won't be useful. So if I click on the message half the time, I would end up wasting half of my time trying to figure out if that is actually where the error is at, because half of the time the compiler doesn't know what the fuck, even the fuck. So I don't know. I'm not going to click the error messages. Maybe if it seems like, if it knows specifically, I'll click it. Other than that, the compiler is a piece of shit. I don't know. Just saying.
Proxy object's target object is false. 2. Perform. Avalite non-revoke C. O. Let target be O. 6. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get unproperty. If trap is undefined, then return. Target. P. Let trap be. Call. Trap. Handler. Target. P. If trap is not an object and trap is not undefined, throw a type error exception. Let target be. Target. P. 0. If trap is undefined, then if target is undefined, return undefined. B. If target is false, throw a type error exception. C. Let extensible target be. Is extensible. Target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be. Is extensible. Target. 2. Let result is be. Top property descriptor. Tripresel.
It's brilliant.
Exception.
I'll be back. I can't sit here and wait so fucking long.
Desk is true. Then I throw a type error exception. B. If result is has a field and result is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result is NOT for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property or the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as a known property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 056. P-desk. The internal method of a proxy exotic object takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Avalite non-revoke C. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Defining property. If trap is undefined, then return. Target. P. Desk. Let desk hub be from property descriptor. Desk. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desk hub. If boolean trap result is false, return false. 0. Let target desk be. Target. P. ECMA International 2024-207. 11. Let extensible target be. Is extensible. Target. 2. If desk has a field and desk is false, then A. Let setting config be true. 13. Else A. Let setting config be false. 4. If target desk is undefined, then if extensible target is false, throw a type error exception. B. If setting config is true, throw a type error exception. 5. Else if is compatible pripter, extensible target desk is false, throw a type error exception. B. If setting config is true and target desk is true, throw a type error exception. C. If is data descriptor, target desk, is true, target desk is false, and target desk is true. Then, if desk has a field in desk, is false, throw a type error exception. 6. Return true. NOT for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding and non-configurable own property.
And looks like it builds. Now a couple more lines of code. Oh, this is terrible. This is so freaking annoying.
Property has a corresponding target object property, then applying the property descriptor or the property to the target object using will not throw an exception. 057 p. The internal method of a proxy exotic object takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform, evaluate and on-revoke C, O, let target be O, let handler be O, assert, handler is an object. Let trap be, get method, handler, has. If trap is undefined, then return, target, P. Trap result be to boolean, call, trap.
I think I found where it's getting stuck. I already started the whole process of going chunk by chunk.
The extensible target me is extensible target 3.
So I think I'm going to continue doing the process of chunk by chunk. Just to make sure, like, I don't know. There's no way to win. I'm going to have to wait a minute and 20 seconds between each motherfucking time I click build. For fuck's sake. My attention span is only so long. I can't take this. So I'm gonna take this nice and slow and just accept that time is ticking away every time I press build.
Containing an ECMAScript.
If you're watching the stream, go away. Don't watch this. You're wasting your life.
On revoke C, O.
I have to wait for it to build.
Object. Let trap be, get method, handler, get.
Use time for at least a minute and 25 seconds. And I have to sit here as time goes. Tick, 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 tick. And if you're sitting here watching this, you're not fast forwarding, you're watching for a minute 25. Nothing. You're waiting for nothing. You get nothing out of sitting there waiting. So do not watch this. Go do something else. Go live your life. Get out of here. So I'm gonna like sit here and live my life waiting for this compiler to build as I click compile another 4 or 5 times. Like, I can't explain how pissed off I am. I'm like so angry, but I'm gonna pretend that I'm happy and this is I'm having a great time. It's a lot of fun.
The non-configurable own act.
This is exciting, so much fun.
PV receiver. The internal method of a proxy exotic object takes arguments P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform, evaluate and on revoke C, O, let target be O.
The operating system, the modern operating system, is a joke. It's a big fucking joke. The operating system is like a window that runs other processes. The processes, they attach to the operating system via a C language program or a program written in assembly language, converted or whatever, to linker and all this bunch of shit. It's a joke. This is bullshit. The compiler should not be separate from the operating system. It should all be one because you can pass in completely invalid instructions and code and crash Windows, because it's like they're both competing for the same resource on the processor. They're literally the same thing. The operating system is like in the same memory as the program memory, and they both compete for memory, except the operating system is able to set privilege modes because they added that to CPU instructions, with like protected mode and an unprotected mode, and they can jump down to like 32-bit mode, back to 64-bit mode, and then they lock the CPU, they run the process, they unlock it, they run operating system stuff, and then they lock it. It's fucking ridiculous. This is not modern. And Windows is shit. Okay, I'm gonna like shut up and just hit compile and do a couple lines at a time of this code. Freaking wait for it to compile the whole fucking thing again for a couple lines of code, because it's not able to optimize and say, oh, the code hasn't changed up to this point, why don't we store the pre-compiled code and then change only what changes past this point. I hate everything. So I'm gonna like sit here and waste my life fucking clicking compile. For fuck's sake. This is stupid.
F11. The internal method.
Windows sucks.
Obtaining a list of property keys, or a throw completion. It performs the following steps when called. Perform. Avalate on revoke C. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Keys. 10. ECMA International 2024 6. If trap is undefined, then return target. Let trap result array be. Call trap handler target. Let trap result be. Create a list from Aramaic trap result array string symbol. If trap result contains any duplicate entries, throw a type error exception 0. Let extensible target be. Is extensible target 1. Let target keys be. Target 2. Assert target keys is a list of property keys. 3. Assert target keys contains no duplicate entries. 4. Let target configure keys be a new empty list. 5. Let target unfuzz keys be empty list. 6.
I'm gonna try to do like a bigger block of code. And hope it doesn't have an issue, so I don't have to like break it up again into smaller pieces and run it.
Turn trap result.
I can't go line by line by line.
9. For each element key of target, figure do A. If unchecked result keys does not contain key, throw a type error exception. B. Remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configure keys do A. If unchecked result.
I need to make a OBS scene that zooms in,
If unchecked,
but I can't because it blurs the screen.
return trap result. Note.
I can't like zoom in like this every single time. I'll just stop doing that. I don't have time to click that and zoom in. I don't know. That's what's happening. Whenever it does this, I'm fucking sitting here waiting for it to build. I'm not doing nothing. I'm waiting for it to build. While the CPU is hardly even being used. 39, 37, there's some background task running. It's usually like 20. This program is compiling, and it's not even using the whole fucking CPU. So I'm gonna wait a fucking minute. For fuck's sake. Oh, it's almost done. Oh, look, it is done. Literally, the CPU usage goes up, right? So it uses 10% CPU to compile, 10-20%, but it doesn't jump until it has to output to the console here. The CPU spends more work outputting this than it does actually compiling the motherfucking code. For fuck's sake, if they would run and compile the code, I wouldn't have to wait a minute and 23 seconds. Like, do you know how pissed off I am? I'm really pissed. Fuck. So it looks like a build. That's positive. I'm gonna just do a couple more lines of code, pass it in the compiler, see if it builds.
Handler, target, array.
I can see where I missed one spot and why we got stuck. So I'm gonna like run this line of code, well, 2 lines of code,
Non-revokes.
and I'll build it, see if it's okay. And I got like a block of code, so I'll build that. And I think I might have an issue, so I'll have to like figure out how to rewrite it so it doesn't mix up the macros or whatever, because it's kind of messy. It's really difficult to read.
Throw a type error exception. Assert proxy is not null. Return unused. 0515 proxy create. Target handler. The abstract operation proxy create takes arguments target and ECMAScript language value and handler and ECMAScript language value and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make passive object. Set P as essential internal methods, except for and, to the definition specified in 10.5. If a callable target is true, then a set P as specified in 10.5.1.2. B if is constructor target is true, then I set P as specified in 10.5.1.3. Set P to target, set P to handler, return P. 12. ECMA International 2024. NOTE1 A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text 1.1 Source text syntax Susca character any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0 to U plus 10 FFFF, including surrogate code points, may occur in ECMAScript source text, where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of Susca character values, each Susca character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. NOTE in string literals, regular expression literals, template literals and identifiers. Any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively
And then build.
ECMAScript differs from the Java programming language in the behavior.
And then wait. This is so slow. For God's sake.
Within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write and instead of U0008 to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript P program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 111 Static Semantics, UTF-16 Encoder Code Point, CP. The abstract operation UTF-16 encoder code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 lesser or equal to CP lesser or equal to 0 times 10 FFFF. If CP lesser or equal to 0x FFFF, return the string value consisting of the code unit whose numeric value is CP. Let Q1 be the code unit whose numeric value is floor, CP. 0 times 10,000, 0 times 400, plus 0xt 800. Let Q2 be the code unit whose numeric value is CP, 0 times 10,000, modulo 0 times 400, plus 0xtc00. Return the string concatenation of CU1 and CU2. ECMA International 2024213. 1112 Static Semantics, Cody point store string, text. The abstract operation Cody point store string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 614. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result in UTF-16 encoder code point, CP. 3. Return result. 113 Static Semantics, UTF-16 surrogate pair to code point, lead, trail. The abstract operation
Hooray. Syntax error.
Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert, lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xt800 times 0x400 plus trail 0xtc00 plus 0 times 10000. Return the code point CP. 114 Static Semantics, code point at string position. The abstract operation code point at takes arguments string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 614, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert, position 0th and position less than size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 false 6. If first is a trailing surrogate or position plus 1 equals size, then return the record CP code unit count 1 true. Let within string, if second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point, first, second, 0. Return the record, CP, 2, false. 115 Static Semantics, string to code point, string. The abstract operation string to code point takes argument string, a string, and return.
Oh, man. I have to this is so confusing.
Be a new empty list. Let size be the length of string.
I broke down the syntax to simplify it. So it's simpler. But it's more complicated.
Source it.
I'll just run it and see how it goes.
Text takes argument source.
I need to like check after
The ECMAScript
to make sure it does what it's supposed to be doing, because
your object. It performs following called.
some spots will like
Pa-
post increment to like increment after a variable on left hand side.
Return the path.
I'm not sure if it's incrementing the correct thing.
Syntax error objects represent. Error is a present. At least one must be.
I don't know. I have to make a parser. This is a set of rules. I can't. I'm not gonna remember all this. I don't have time to like look up
Generator declaration, generator expression.
freaking what goes where. This is so annoying. I need to make a parser. Oh man, so annoying. Oh well, I'll run it. Then I just want 0 errors. And then I can dig in to like make sure each line does what each line is supposed to do.
Portion of that script function code is sourced x, that is parse. 2. An ECMAScript function. The function code of a particular ECMAScript function does not include any sourced x that is passed as the function code of a nested function.
And then build. And then wait. Wait. I can't stand waiting.
Or, the formal parameters in async generator body of an async generation or async generator expression, then the sourced x matched by the binding identifier, if any, or that declaration or expression is also included in the function code of the corresponding function. Module code is sourced x, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1 Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse pass followed by an early errors pass might report the syntax error, and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error, and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024215. Text that is passed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function, async generation, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note1 function code is generally provided as the bodies of function definitions 15.2, arrow function definitions 15.3, method definitions 15.4, generator function definitions 15.5, async function definitions 15.8, async generator function definitions 15.6, and async arrow functions 15.9. Function code is also derived from the arguments to the function constructor 2211, the generator function constructor 27311, and the async function constructor 27711. Note2 The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier, that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict. Mode code 1-to-1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression scenes occurring as the initial statement or list items or module items of a function body, a script body, or a module body, and where each expression sequence in the sequence consists entirely of a string letter token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression sequence in a directive prologue whose string literal is either of the exact code point sequences, use strict, or use strict. A use strict directive may not contain an escopy sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 122 strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 432. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function, async generation, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that when processed is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note: the expression sequence of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression sequence which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression sequence that is not a use strict directive and which does not have a meaning defined by the implementation. 11.3 Non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or is a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language, lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple gold symbols for the lexical grammar. The input element #goal is used at the start of a script or module. The input element eject goal is used in syntactic grammar contexts where a regulator X, a template middle, or a template tail is permitted. The input element rejects goal symbol is used in all syntactic grammar contexts where a regulator X is permitted but neither a template middle nor a template tail is permitted. The input element tailed goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regulator X is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note: the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regulator X are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: up equals b, hi, g.exec, c, map, d. where the first non-white space, non-comment code point after a line terminator is U plus 002F, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as A equals B. Hi, G.exec, C, map, D. Syntax input element div, white space, line terminator comment command token de punctuator right brace punctuator input element regex, white space, line terminator comment command token right brace punctuator regulator x, ECMA International 2024217 input element regex plate, white space, line terminator comment command token regulator x template substitution tail input element tilt, white space, line terminator comment command token de punctuator template substitution tail input element hashabang, white space, line terminator comment command token hashabunkim and regulator x. 2.1 Unicode format control characters. The Unicode format control characters, i.e., the characters in category CF in the Unicode character database, such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher-level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus FEFF, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding in byte order. Less than win best pp. Characters intended for this purpose can sometimes also appear after the start of a text, for example as a result of concatenating files. In ECMAScript source text less than win best pp. Code points are treated as white space characters, see 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FEFF 0 width no break space ZWNBSP white space. 218 ECMA International 2024.
And it builds. Yeah, I'm not gonna go sit here for every minute, 20 seconds. Let's jump through.
Input. White space code points may occur within a string literal, a regulator X, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. Table 36, white space code points. Code points. Name, abbreviation, U plus 0009. Character tabulation, TAB, U plus 000B. VT, U plus 000C. Form feed, FF, U plus FEF.
Alright, this will build.
Any code point in general category. Space separator USP NOT1.
It's way too long to wait between builds for holy crap.
No break space. Code points are part of less than USP syntax. NOT2 other than for the code points listed in Table 36. ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not cell-specified in general category. Space separator SS. 2.3 white space less than tab VT FF less than ZWNBSP less than USP line terminators. Like white space code points, line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, Line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail. Less than LLF, and less than CR, line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024219. The ECMAScript line terminator code points are listed in Table 37. Table 37, line terminator code points. Code point. Unicode name. Abbreviation. U+000A. Line feed. LF U+000D. Carriage return. CR U+2028. Line separator LS U+2029. Paragraph separator PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators, but are treated as whitespace if they meet the requirements listed in Table 36. The sequence less than CR, less than LLF, is commonly used as a line terminator. It should be considered a single SUSCA character for the purpose of reporting line numbers. Syntax: line terminator, less than LLF, CR, less than LS, less than SPs. Line terminatons, less than LLF, CR, LOOKAHEAD less than LLF, less than LS, PS, CR, less than LLF. 2.4 Comments. Comments can be either single or multi-line. Multi-line comments cannot
I do have over 100 files. So 30 seconds to several minutes. I guess that makes sense. So stupid. I hate everything. It's done. Admit I think I built. Hooray. God, it's so slow.
considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax: comment, multi-line NT, single line comment. 20. ECMA International 2024. Multi-line comment, multi-line comments op chopped, multi-line commentures, multi-line note esco multi-line comments op chopped, post asterisk mep chop, post asterisk commentures, multi-line art forward asterisk charward asterisk charda isk char multi-line comments op chopped, post asterisk mep chopped, multi-line note esco, suska character but not, multi-line art forward asterisk charward asterisk charda isk char. Suska character but not one or single line comment, single line comment chopped, single line commentures, single line commentures, single line comment chopped, single line commentures, Suska character but not line terminator. A number of productions in this section are given alternative definitions in section B1112.5. Hashbang comments. Hashbang comments are location sensitive and, like other types of comments, are discarded from the stream of input elements for the syntactic grammar. Syntax: hashbang comment, single line comment chopped. 2.6 Tokens. Syntax: command token, identifier name, private identifier, punctuator, numeric literal string literal template, NOT the DE punctuator, regulator X, right brace punctuator, and template substitution. Tail productions derive additional tokens that are not included in the command token production. ECMA International 2024221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31, identifier in pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points in the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier start, identifier name, identifier part, identifier start, identifier starter, Unicode ESCOPCC, identifier part, identifier parcher, Unicode ESCOPCC, identifier starter, Unicode ID start, identifier parcher, Unicode diet continue. ZWNJ, less than Zwajj. ASCII letter, one of Abdifkikelas Napsaniark. Unicode ID start. Any Unicode code point with the Unicode property, ID start. Unicode diet continue. Any Unicode code point with the Unicode property, ID continue. Standard specifies specific code point additions, U+0024, $, and U+005F, LO.
I'll build it to make sure it runs again, and then I'll run it. But then I gotta freaking check to make sure that each line's working correctly. Oh my god, it's so freaking long to build.
Code point equal to the identifier code point of the Unicode ESCOPC.
So it's building. And then I'm waiting. I can't believe that the screen gets blurry when you scale or zoom in. This stuff is
The result must still be a valid identifier name that has the exact.
it's vector or whatever, vector art basically. Especially the text and the lines. They should recompute whatever the area of the screen is zoomed in on, instead of make it all blurry and fuck. Cause like I'm zooming on the OS, they should just rescale, re-render, and keep it crisp. Instead it's like fucking blurry and aliased.
Identifier part, Unicode CC. Error. Code point of CC is not some Unicode code point matched by the identifier partial lexical grammar production 2712.
Finished in 1, 2, 3.
Of code points. It is defined piecewise over the following productions. Identifier name, identifier start. Let CP be identifier code point of identifier start. Return CP identifier name, identifier.
I wonder if I'll ever get 1, 2, 3, 4, 5, 6. It'd be so amazing, but not really. I'm so freaking bored. This is so boring. So now I'm gonna run it.
Directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions. Identifier start, identifier starter. Return the code point matched by identifier starter. NOT3 the sets of code points with Unicode properties, ID start, and ID continue, include, respectively, the code points with Unicode properties, other ID start, and other ID continue. ECMA International 2024223. Identifier part, identifier part.
I think it pops up like that when it hits an error.
The MV of code point 272 keywords and reserved words. A keyword is.
But it's not an error, I just ignore whatever the operation was when there's an issue. So I need to catch whatever. But I think some are like popping up because those are the ones I was debugging 7 years ago whenever I wrote this. But it made it to the bottom. And it printed.
Specify which names are valid identifiers and which are reserved words.
The JavaScript variable to the council. I spent whatever yesterday getting to work.
Fires. See 13.11, 14.311, 14.751, and 15.7.1. In summary, there are 5 categories of identifier names: those that are always allowed as identifiers and are not keywords,
Like, I'll copy some.
those that are never allowed as identifiers, namely the reserved words listed below except await and yield; those that are contextually allowed as identifiers, namely await and yield; those that are contextually disallowed as identifiers, in strict mode code, let, static, implements, interface, package, private, protected, and public; those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, or set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some tags. Reserved word 1 or await break case catch class const continue debugger default delete 2 else no export extends false finally for function if import in instance of new null return super switch this throw true try type of var void while with yield. 24 ECMA International 2024 NOTE 1 per 515 keywords in the grammar match literal sequences of specific SUS character elements. A code point in a keyword cannot be expressed by a Unicode esque PCC. An identifier name can contain Unicode esque sequences, but it is not possible to declare a variable named else by spelling it else. U65. The early area rules in 13.11 rule out identifiers with the same string value as a reserved word. NOTE2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. NOTE3 The names arguments and evil are not keywords, but they are subject to some restrictions in strict mode code. See 13.11, 864, 15.21, 15.51, 15.6, 8.1, 2.8. Punctuator, optional chaining punctuator or the punctuator optional chaining punctuator look ahead decimal digit or the punctuator 1 or less than equals plus percent plus less than and equals plus equals percent equals less than equals and equals to the power equals and
Like this one, whatever. It's fine.
equals right brace punctuator 2.9 literals 291 null literal syntax null literal null ECMA International 2024225 1292 Boolean literal syntax Boolean literal.
I think it's something assigning it to one or whatever. This one.
Brick literal decimal literal decimal bigger literal non-decimal literal plus sep non-decimal literal plus sep bigent literal suffix legacy octalittle interior literal decimal bigger literal 0 bigent literal suffix non-zero.
I think it's an object. It acts the same property of an object. It's setting equal to whatever's on the right hand side, but whatever's on the right hand side, it says error to operand A infield right hand property. This one's the best. I know what the fuck is doing.
Numeric letter up to separator up to decimal digits plus sep non-octesimetal decimal digits sep decimal digit sep decimal digit plus sep decimal digits plus sep numeric literal separator decimal digit 1/0 1 2 3 4 5 6 7 8 9 26 ECMA International 20.
So I gotta figure out these ones. And build our hand. I think they're all basically property accesses, maybe. Except this one says 5, this one says 2, this one says 2. So I should like do Control F and figure out what counts as error 2 operand A and what counts as error 5 operand E. I don't know why I have operand E.
Sep octal digit plus sep little interior little octal digit non-octesimetal 0 non-octal digit legacy octal literal non-octal digit non-octesimetal legacy octal.
This is so boring. I'll be back. But it looks like it builds. I'm gonna save it back up.
4227 hex integer literal sep 0x hex digits sep 0x hex digits sep hex digits sep hex digit sep hex digit plus sep hex digits plus sep numeric literal separator hex digit 1/0 1 2 3 4 5 6 7 8 9 absifaldef. The Suska character immediately following a numeric literal must not be an identifier start or decimal digit. 2931 static semantics.
Oh, this computer's so slow.
Decimetal. It is a syntax error if the source text matched by this production is strict mode code. NOTE in non.
The computer does more work moving files than it does when it compiles. The compiler does less work compiling code than it does when it's transferring files. That's cool.
Decimal digits times 10, n, where n is the number of code points in decimal digits, excluding all occurrences of
So I'm gonna copy, I'll open it again.
decimal integral. Exponent part is the MV of decimal integral. 10e, where e is the MV of exponent part. The MV of decimal literal. Decimal integral. Decimal digits exponent part is the MV of decimal integral plus the MV of decimal digits times 10, n, times 10e, where n is the number of code points in of numeric literal separator.
In my notes. Need some more water. I need stopwatch. So I'm gonna find stopwatch or whatever. I'm just gonna make a new one. I don't wanna wait between compile times to test if something works or not. Because I have macros to stopwatch things, but they're complicated. And they use like global variables, and it'll like mess something else up if I like use it without. I'm just gonna make a new chatbot. So I'll make a stopwatch, and I think that's it for this stream because I'm tired. This is so fucking boring. I might figure out which ones are messed up.
Is the MV of decimal
Right hand operand, whatever.
digits numeric little separator decimal digit is the MV or decimal digits times 10 plus the MV of decimal digit.
But I don't know if I have the attention span. It's gonna take waiting here. The lag, I could have restarted something.
8. ECMA International 2024. Note, for example,
So I'll get a stopwatch when I get back. I'll make sure it works. It's accurate, whatever. I'll put the, does it sleep or something and see. I'll sleep the program with the sleep call, system call. And then I'll check the stopwatch to make sure like it matches however long or as close to the time I set the computer to sleep. If that's good, I have the stopwatch ready. And then I need to just fix the operands that I messed up. And then I can run a speed test. I don't know, that's about it. So I think getting a stopwatch and maybe a couple of the operations that are showing or throwing
5 or of hex digit 5 or
whatever ones that are throwing this issue 2 or 5, I don't know. I do control F to find where. I don't remember. Whatever it relates to, the number and whatever. I might fix like a couple of these. And I think that's it. And then next stream, I'll get the loop. But I have to fix whatever that are left of these that have an issue. And then I'll do the loop. So next stream I'll finish making sure like it's actually converted and does the same operations as the browser. And I'll be able to run it and speed test it. Unless I have enough energy to just finish and do the speed test. But I got a headache. I'm not in the mood to put up with fucking waiting 2 goddamn minutes every time I fucking hit compile. It's so long to wait. So I don't know. I might get back. I'll at least do stopwatch. Do that. At least then all this is done. And then all that's left is fixing the operands and testing it speed. And then now after that I'll be able to convert the rest to 64-bit. Maybe 2-3 days. Possibly 4. And then pickle business. We're gonna pick between one pickle or the other. Do I want? Or like, we're using hash tables to be faster than caching, and then using the cache and only accessing the hash table when something's not cached. So I'm gonna pick between this pickle or this pickle. Because I'm gonna pickle, I gotta pick one or the other. I'm gonna have to literally write code for both to test them both, because I don't know till I run it. So I'm gonna have to waste time making both pickles, and then whichever pickle is fastest, it's the pickle I'm gonna pick. What is it? Peter Piper picked a something peppers pickles pickle. I don't know. I can't focus. I don't care right now. And then after that, then I'm on to standard, because I'll have whichever one that's faster
0 byte literal
set up or whatever. And just pick that pickle and then go with it.
value for the MV of non-zero digit decimal bit.
And it's I don't know. Any optimizing I'm gonna do after I get the standard met. So once I get which pickle method I'm going to use with the extra cache or no extra cache, because the caching might not help with the hash map, the maps, hash table, whatever you want to call them. It might, I don't know until I try it, but I think it might speed them up. And that also involves when it's an array or a hash map. I'm going to make a bit later to indicate that, so I'll have to like account for that, but for now I'll just make everything take the branch as a hash map, and then I'll add arrays in later. Like when I meet the whole standard, I'll put support for arrays, so I can like just get this thing fucking running, because this can take forever to meet in the first place. I don't want to like spend all my time doing all this like pre-stuff just to get to the standard. Once I get the whole thing, I have to do this little speed test, whatever. It's taking too long. It's almost done now. But once I get the whole thing to 64-bit, I pick which build mode to use with the extra cache or not. Then it's the standard. Now I'm gonna, the epilogue, whatever, I'm gonna have to optimize things or whatever after. Because this is the goal. And this is kind of like, I meet the standard, or I don't. So this is like the known of things that are unknown. If I go back and forth with picking which build mode to use, or I spend a lot of time optimizing things and figuring out which is faster, speed testing things, I'm gonna just be wasting time in circles. So I gotta get to here. And I was gonna render a demo in OpenGL to show that my JavaScript engine is faster and that it can compute more between frames. And I'll like lockstep the frame rate on purpose, because a lockstep is a good way to show either it does the amount of work before each frame or not. Like that's the only reason I would lockstep it, is for that reason, because clearly lockstepping doesn't work if you have too much to compute. It's gonna lag. But it's easier to show that the amount of work done is more than another one if one doesn't lag as the amount of work increases each frame. But this also adds to if I do this, it's gonna eat up time. My whole point is to just meet the standard here. So I'm not gonna do this. I might do this later in the epilogue, maybe. That'd be better.
Character
Oh, I might-
bring correct.
I might do that later, whatever. So I'm gonna find a stopwatch or whatever as chatbot. I'll test to make sure it's accurate. And BRB.
Of double string character, Susca character but not one or limit terminator is the result of performing UTF-16 encoder code point on the code point matched by Susca character. The SV of double string character, less than ls, is the string value consisting of the code unit 0 times 2028 line separator. The SV of double string character, less than s piece, is the string value consisting of the code unit 0 times 2029. Paragraph separator, the SV of double string character. Line continuation is the empty string, the SV of single string character. Susca character but not one or limit terminator is the result of performing UTF-16 encode code point on the code point matched by Susca character. The SV of single string character less than ls is the string value consisting of the code unit 0 times 2028. Line separator, the SV of single string character less than s piece is the string value consisting of the code unit 0 times 2029. Paragraph separator, the SV of single string character. Line continuation is the empty string, the SV of s copy sequence. 0 is the string value consisting of the code unit 0 times 0. NULL, the SV of character is copy sequence. Single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. NOTE2 It is possible for string literals to proceed a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BST 0 times 9. Character tabulation. HTN 0 times 000A. Line feed. LF V 0 times 0B. Line tabulation. VT F 0 times 0C. Form feed. FF R 0 times 000D. Carriage return. CR 0 times 22. Quotation mark. 0 times 0027. Apostrophe. 0 times 5C. Reverse solidus. The SV of non-escape character. Susca character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by Susca character. The SV of s copy sequence. Legacy octal sequence is the string value consisting of the code unit whose numeric value is the MV of legacy octal sequence. The SV of non-octal decimal sequence. 8 is the string value consisting of the code unit 0 times 38. Digit 8. The SV of non-octal decimal sequence. 9 is the string value consisting of the code unit 0 times 39. Digit 9. The SV of hex s copy sequence. Hex digit is the string value consisting of the code unit whose numeric value is the MV of hex s copy sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the MV of hex 4 digits. The SV of Unicode s copy CC. U. Code point is the result of performing UTF-16 encode code point on the MV of code point. The SV of template s copy C. 0th is the string value consisting of the code unit 0 times 0. NULL. 12943 Static semantics. MV. The MV of legacy octal sequence. 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal sequence. 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal sequence. 0 to 3 octal digit is 64, that is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0th is 0. The MV of 0 to 3. First is 1. The MV of 0 to 3. Second is 2. The MV of 0 to 3. Third is 3. The MV of 4 to 7. Fourth is 4. The MV of 4 to 7. Fifth is 5. The MV of 4 to 7. Sixth is 6. The MV of 4 to 7. Seventh is 7. The MV of hex s copy sequence. Hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 times the MV or the first hex digit plus 0 times 100 times the MV of the second hex digit plus 0 times 10 times the MV of the third hex digit, plus the MV of the fourth hex digit. ECMA International 20242333 1295 regular expression literals. The productions below describe the syntax for a regular expression literal, and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the reg and expression bar and body 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 and bar, and the reg and expression flags are subsequently passed again using the more stringent ECMAScript regular expression grammar 2221. An implementation may extend the ECMAScript regular expression grammar defined in 2221, but it must not extend the reg and expression bar and body 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 and bar and reg and expression flags productions defined below or the productions used by these productions. Syntax: regulator X, reg and expression bar and body 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 and bar. Reg and expression flags, reg and expression bar and body 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 and bar. Regular extension first to regular expression, empty, regular expression, regular extension first to regular expression not a but not one or, regular expression backslash, regular expression, regular expression not a but not one or, regular expression backslash, regular expression backslash, regular expression not a, Suska character but not terminator, regular expression and classion, empty, regular expression and classion, regular expression car, regular expression not a but not one or, regular expression backslash. NOTE1 A regular expression literal is an input element that is converted to a regexp object, see 22.2, each time the literal is evaluated. Two regular expression literals in a program evaluate two regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp, or calling the regexp constructor as a function, see 22.24. 34. ECMA International 2024. Reg and expression flags. Empty. Reg and expression flags identify aperture. 2951 Static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regulator X, reg and expression bar and body 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 and bar. Reg and expression flags. Return the source text that was recognized as reg and expression bar and body 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 and bar. 12952 Static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regulator X, reg and expression bar and body 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 and bar. Reg and expression flags. Return the source text that was recognized as reg and expression flags. 1296 Template literal lexical components. Syntax: template. No substitution template. Template head. No substitution template. Template character subt. Template head. Template character sub $. Template substitution tail. Template middle. Template tail. Template middle. Template character sub $. Template tail. Template character subt. Template characters. Template character. Template character subt. NOTE2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use ECMA International 2024-235. Template character. Look ahead. Template scope C. Note escape sequence. Line continuation. Line terminatons. Suska character but not one or $, or line terminator. Template scope C. Characteristic sequence. Look ahead decimal digit. Hex scope sequence. Unicode scope CC. Note escape sequence. 0th decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. code point, look ahead hex digit, look ahead not code point, hexdigits, approximately sep, but only if MV of hex digits greater than 0 times 10th FFFF code point, hexdigits, approximately sep, but only if MV of hex digits lesser or equal to 0 times 10 FFFF. Note template substitution tail is used by the input element tail to alternative lexical goal. 12961 Static semantics, TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the indexed components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code unit, S, or the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $ is the empty string. The TV of template middle, $ is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined, or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, character but not one or $, or line terminator, is the result of performing UTF-16 encoder code point on the code point matched by character. The TV of template character, $ is the string value consisting of the code unit 0 times 24, $sign. The TV of template character, template is the SV of template. The TV of template character, note escape sequence is undefined. The TV of template character, line terminatons is the TRV of line terminatons. 236, copyright sign, ECMA International 2024. The TV of line continuation, line terminatons is the empty string. 12962 Static semantics, TRV. The syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $ is the empty string. The TRV of template middle, $ is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, character but not one or $, or line terminator, is the result of performing UTF-16 encoder code point on the code point matched by character. The TRV of template character, $ is the string value consisting of the code unit 0 times 24, $sign. The TRV of template character, template is the string concatenation of the code unit 0 times 5c, reverse solidus, and the TRV of template the TRV of template character. Note escape sequence is the string concatenation of the code unit 0 times 5c, reverse solidus, and the TRV of note escape sequence. The TRV of template 0th is the string value consisting of the code unit 0 times 30, digit 0. The TRV of note escape sequence, 0th decimal digit is the string concatenation of the code unit 0 times 30, digit 0, and the TRV of decimal digit, the TRV of note escape sequence, x, look ahead hex digit, is the string value consisting of the code unit 0 times 78, Latin small letter x. The TRV of note escape sequence, x hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 78, Latin small letter x, and the TRV of hex digit, the TRV of note escape sequence, u, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 75, Latin small letter u. The TRV of note escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 75, Latin small letter u, and the TRV of hex digit, the TRV of note escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 75, Latin small letter U, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of note escape sequence, U hex digit hex digit hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 75, Latin small letter U, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit, the TRV of note escape sequence, U, look ahead hex digit, is the string concatenation of the code unit 0 times 75, Latin small letter U, and the code unit 0 times 7b, left curly bracket, the TRV of note escape sequence, U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 75, Latin small letter U, the code unit 0 times 7b, left curly bracket, and the TRV of not code point, the TRV of note escape sequence, U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 75, Latin small letter U, the code unit 0 times 7b, left curly bracket, and the TRV of code point, the TRV of decimal digit, 1 of 0 1 2 3 4 5 6 7 8 9, is the result of performing UTF-16 encode a code point on the single code point matched by this production, the TRV of character is coefficients. Non-scaper character is the SV of non-scaper character, the TRV of singly scaper character, 1 or BFNRTV is the result of performing UTF-16 encode a code point on the single code point matched by this production, the TRV of hex escopy sequence, X hex digit is the string concatenation of the code unit, 0 times 78, Latin small letter x, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of Unicode escopy CC. U hex 4 digits is the string concatenation of the code unit, 0 times 75, Latin small letter U, and the TRV of hex 4 digits, the TRV of Unicode escopy CC. U, code point, is the string concatenation of the code unit, 0 times 75, Latin small letter U, the code unit 0 times 7b, left curly bracket, the TRV or ECMA International 2024237 code point, and the code unit 0 times 7d, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV or the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit, the TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits in the TRV of hex digit, the TRV of hex digit, 1 of 0 1 2 3 4 5 6 7 8 9, a BCDEF. A BCDEF is the result of performing UTF-16 encode a code point on the single code point matched by this production, the TRV of line continuation. Lineterminatons is the string concatenation of the code unit, 0x5c, reverse solidus, and the TRV of lineterminatons. The TRV of lineterminatons, less than LLF, is the string value consisting of the code unit 0 times 000a line feed. The TRV of lineterminatons, less than CR, is the string value consisting of the code unit 0 times 000a line feed. The TRV of lineterminatons, less than LS, is the string value consisting of the code unit 0 times 2028 line separator. The TRV of lineterminatons, less than S piece, is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of lineterminatons, less than CR, less than LLF. is the string value consisting of the code unit 0 times 000a, line FED 2.10 automatic semicolon insertion. Most ECMAScript statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2101 Rules of Automatic Semicolon Insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are three basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line determinator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon. Or a while statement, 14.7.2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal. Then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line determinator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line determinator. Then a semicolon is automatically inserted before the restricted token. NOTETV excludes the code units of line continuation while TRV includes them. Less than CR, less than LLF, and less than CR, line determinator skinses are normalized to less than LLF, for both TV and TRV. An explicit template SCPC is needed to include a less than CR, or less than CR, less than LLF, sequence. 38. ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the two semicolons in the header of a for statement. See 14.7.4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left the expression, yield, await. No line determinator here. ++ left the expression, yield, await. No line determinator here. Continuous statement, yield, await. Continue, no line determinator here. Label identifier, yield, await. Break statement, yield, await. Break. No line determinator here. Label identifier, yield, await. Return statement, yield, await. Return, no line determinator here. Expression, +in, yield, await. Throw statement, yield, await. Throw, no line determinator here. Expression, +in, yield, await. Yield expression, in, await. Yield, no line determinator here. Assignment expression, in, plus yield, await. Yield, no line determinator here. Assignment expression, in, plus yield, await. Arrow function, in, yield, await. Arrow parameters, yield, await. No line determinator here, equals. Concise body, in, async declaration, yield, await. Default, async, no line determinator here. Function binding identifier, yield, await. FORMALPRAMETERS, approximately yield, plus await. Async function body, plus default, async, no line determinator here. Function, FORMALPRAMETERS, approximately yield, plus await. Async function body, async function, async, no line determinator here. Function BINDINGIDENTIFIER, approximately yield, plus await, opt. FORMALPRAMETERS, approximately yield, plus await. Async function body, async method, yield, await. Async, no line determinator here. Class element name, yield, await. Unique form parameters, approximately yield, plus await. Async function body, async enredition, yield, await. Default, async, no line determinator here. Function, binding identifier, yield, await. Formal parameters, plus yield, plus await. Async generator body, plus default, async, no line determinator here. Function, formal parameters, plus yield, plus await. Async generator body, async narrator expression, async, no line determinator here. Function, binding identifier, plus yield, plus await, opt. Formal parameters, plus yield, plus await. Async generator body, async generated, yield, await. Async, no line determinator here. Class element name, yield, await. Unique form parameters, plus yield, plus await. Async generator body, async arrow function, in, yield, await. Async, no line determinator here. Async arrow buyer, yield, No limiter here equals async inside body in covocal expression in the head yield await. No limiter here equals async inside body in ECMA International 2024239 async arrowhead async. No limiter here arrow formal parameters approximately yield plus await. The practical effect of these restricted productions is as follows. When a ++ or token is encountered where the parser would treat it as a postfix operator, and at least one limiter occurred between the preceding token and the ++ or token, then a semicolon is automatically inserted before the ++ or token. When a continue, break, return, throw, or yield token is encountered and a limiter is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter s are followed by a limiter before a equals token, semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a limiter before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a limiter before a token, a semicolon is automatically inserted, and the punctuator causes a syntax error. The resulting practical advice to ECMAScript programmers is, a postfix ++ or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter, s, and its equals, should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2102 Examples of automatic semicolon insertion. This section is non-normative. The source 12.3 is not a valid sentence in the ECMAScript grammar, even with the automatic semicolon insertion rules. In contrast, the source 123 is also not a valid ECMAScript sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMAScript sentence. The source 4, B40, copyright sign, ECMA International 2024, is not a valid ECMAScript sentence, and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source return a plus b is transformed by automatic semicolon insertion into the following return a plus b. The source a equals b plus plus c is transformed by automatic semicolon insertion into the following a equals b plus plus c. The source if b else c equals d is not a valid ECMAScript sentence, and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point, because an automatically inserted semicolon would then be passed as an empty statement. The source of equals b plus d plus c, print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call of equals b plus c, d plus c, print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2103 Interesting cases of automatic semicolon insertion. This section is non-normative. Note 1 The expression a plus b is not treated as a value to be returned by the return statement, because a limiter separates it from the token return. Note 2 The token plus plus is not treated as a postfix operator applying to the variable b, because a limiter occurs between b and plus plus. ECMA International 2024241. ECMAScript programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMAScript, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when passed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMAScript 21031. Interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a cal expression, an opening square bracket. Without a semicolon, the two lines together are treated as property access, rather than an array literal or array assignment certain, a template literal. Without a semicolon, the two lines together are interpreted as a tagged template, 13311, with the previous expression as the member expression, unary plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regex literal. Without a semicolon, the two lines together may be passed instead as the multiplicative operator. For example, if the regex has flags, 21032 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMAScript contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional upper ends in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here. In this version of ECMAScript 21031, list of grammar productions with optional upper ends and no line terminator here. Update expression, continuous statement, break statement, return statement, yield expression, async function definitions 15.8, with relation to function definitions 15.2. 42. ECMA International 2024. 13. ECMAScript language, expressions 3.1. Identifiers syntax, identifier reference, yield, await, identifier, approximately yield, yield, approximately await, await, binding identifier, yield, await, identifier, yield await, label identifier, yield, await, identifier, approximately yield, yield, approximately await, await, identifier, identifier name but not reserved word. 311. Static semantics, early errors. Binding identifier, identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or evil. Identifier reference, yield binding identifier, yield label identifier, yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference, await binding identifier, await label identifier, await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier, yield, await, yield. It is a syntax error if this production has a yield parameter. Binding identifier, yield, await, await. ECMA International 2024-243. Yield and await are permitted as binding identifier in the grammar, and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0. It is a syntax error if this production has an await parameter, identifier reference, yield, await, identifier binding identifier, yield, await, identifier label identifier, yield, await, identifier. It is a syntax error if this production has a yield parameter and string value of identifier is yield. It is a syntax error if this production has an await parameter and string value of identifier is await identifier, identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is 1 or implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module, and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 312. Static semantics, String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier part. Let it text unscup be identifier code points of identifier name. Return code points to string. It text unscupt. Identifier reference. Yield binding identifier. Yield label identifier. Yield. Return. Yield. Identifier reference. Await binding identifier. Await label identifier. Await. Return. Await. Identifier. Identifier name but not reserved word. Return the string value of identifier name. Private identifier. Identifier name. Ret. Run the string concatenation of 0 times 23, number SIGN, and the string value of identifier name. Modally export name. String literal first. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024 1313 Runtime Semantics, Evaluation, Identifier Reference, Identifier, Return, Resolve Binding, String Value of Identifier, Identifier Reference, Yield, Return, Resolve Binding, Yield, Identifier Reference, Await, Return, Resolve Binding, Await. NOTE1 The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression, yield, await. This identifier reference, yield, await. Literal. Array literal, yield, await. Object literal, yield, await. Function expression. Class expression, yield, await. Generator expression. Async function. Async inheritor expression. Regulator x. Template literal, yield, await, approximately tag, cover-parent-rest cn list, yield, await, cover-parent-rest cn list, yield, await. Expression, plus in, yield, await. Expression, plus in, yield, await. Binding identifier, yield, await. Binding pattern, yield, await. Expression, plus in, yield, await. Binding identifier, yield, await. Expression, plus in, yield, await. Binding pattern, yield, await. NOTE2 In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await. Cover-parent-rest cn list, yield, await. The interpretation of cover-parent-rest cn list is refined using the following grammar. Parenthesized expression, yield, await. Expression, plus in, yield, await. 321 The skyword. 3211 Runtime semantics, evaluation. Primary expression, this, return, resolve ending. 322 Identifier reference. See 13.1 for identifier reference. 1323 Literals. Syntax. Literal, null literal, boolean literal, numeric literal, string literal. 3231 Runtime semantics, evaluation. Literal, null literal 1. Return null literal, boolean literal. If boolean literal is the token false, return false. If boolean literal is the token true, return true. Literal, numeric literal. Return the numeric value of numeric literal as defined in 1293. Literal, string literal. Return the SV of string literal as defined in 12942. 46. ECMA International 2024 1324 Array initializer. Array elements may be eli, dead at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, i.e., a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal, yield, await. Illusionopt elementalist, yield, await. Elementalist, yield, await. Illusionopt elementalist, yield, await. Illusionopt assignment expression, plus in, yield, await. Illusionopt sprept element, yield, await. Elementalist, yield, await. Illusionopt assignment expression, plus in, yield, await, elementalist, yield, await, illusion upscript element, yield, await, illusion, script element, yield, await, assignment expression, plus in, yield, await, 13241 runtime semantics, arraculation. The syntax-directed operation arraculation takes arguments array, and next index, an integer, and returns either a normal completion containing an integer, or an abrupt completion. It is defined piecewise over the following productions. Illusion, let lee be next index plus 1. Perform, set, array, length, lee, true, note. The above step throws if lee exceeds 232, 1. Return lee illusion, return, arraculation of illusion with arguments array and next index plus 1. Elementalist, illusion at assignment expression. If illusion is present, then a set next index 2. Arraculation of illusion with arguments array and next index. Let an int result be evaluation of assignment expression. Let init value be get value. Init result perform created at throw array toString next index. Init value return next index plus 1. Note an array literal is an expression describing the initialization of an array using a list or 0 or more expressions, each of which represents an array element enclosed in square brackets. The elements need not be literals, they are evaluated each time the array initializer is evaluated. ECMA International 2024247. Elementalist, illusion upscript element. If illusion is present, then a set next index 2. Arraculation of illusion with arguments array and next index. Return, arraculation of script element with arguments array and next index. Elementalist, illusion at assignment expression. Set next index 2. Arraculation of elementalist with arguments array and next index. If illusion is present, then a set next index 2. Arraculation of illusion with arguments array and next index. Let an int result be evaluation of assignment expression. Let init value be get value. Init result perform created at throw array toString next index. Init value return next index plus 1. Elementalist, illusion upscript element. Set next index 2. Arraculation of elementalist with arguments array and next index. If illusion is present, then a set next index 2. Arraculation of illusion with arguments array and next index. 3. Return, arraculation of script element with arguments array and next index. Script element, assignment expression. Let spread ref be evaluation of assignment expression. Let spread odd be get value. Spread ref, let iterator record be get iterator. Spread ob, sync, repeat. Let next be iterator step value. Iterator record be if next is done. Return next index. C perform created at throw array toString next index. Next d set next index to next index plus 1. Note created at throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3242. Runtime semantics, evaluation. Array literal, illusion out, let array be, array create, 0. If illusion is present, then a perform, arraculation of illusion with arguments array and 0. 3. Return array. Array literal, elementalist, let array be, array create, 0. Perform, arraculation of elementalist with arguments array and 0. Return array. Array literal, elementalist, illusion out. 2. Let array be, array create, 0. Let next index be, arraculation of elementalist with arguments array and 0. 48. ECMA International 2024. 3. If illusion is present, then a perform, arraculation of illusion with arguments array and next index. Return array. 325. Object initializer. Syntax. Object literal, yield, await. Proper to definition list, yield, await. Proper to definition list, yield, await. Proper to definition list, yield, await. Proper to definition, yield, await. Proper to definition list, yield, await. Proper to definition, yield, await. Proper to definition, yield, await. Identifier reference, yield, await. Cove initializer name, yield, await. Property name, yield, await. Assignment expression, plus in, yield, await. Method definition, yield, await. Assignment expression, plus in, yield, await. Property name, yield, await. Letter L property name, computed property name, yield, await. Letter L property name, identifier name, string letter L numeric literal, computed property name, yield, await. Assignment expression, plus in, yield, await. Cove of initializer name, yield, await. Identifier reference, yield, await. Initializer, plus in, yield, await. Initializer, in, yield, await. Assignment expression, in, yield, await. NOTE2 method definition is defined in 15.4. NOTE1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys, and associated values, enclosed in curly brackets. The values need not be literals, they are evaluated each time the object initializer is evaluated. Copyright sign, ECMA International 2024249. NOTE3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cove of initializer name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3251 Static semantics, early errors. Property definition, method definition. It is a syntax error if a has direct super of method definition is true. It is a syntax error if private bounded identifiers of method definition is not empty. In, used as a cover grammar for object assignment Saturn, and may be recognized as part of a covariant Stressian list. When object literal appears in a context where object assignment Saturn is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a covariant Stressian list or covocal expression head-to-head. Property definition, cove of initializer name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property list of property definition list contains any duplicate entries for proto, and at least 2 of those entries were obtained from productions of the forum. Property definition, property name, assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON.parse. See step 4 of JSON.parse. 3252 Static semantics is computed property. The syntax directed operation is computed property takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, letter L property name, return false. Property name, computed property name, return true. Addition to describing an actual object initializer, the object literal productions are also 250 ECMA International 2024. NOTE1 This production exists so that object literal can serve as a cover grammar for object assignment Saturn. It cannot occur in an actual object initializer. NOTE2 The list returned by property name list does not include property names defined using a computed property name. 13253 Static semantics, property name list. The syntax directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list, property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list, property definition list, property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3254 Runtime semantics, evaluation. Object literal. Return ordinary object crib. %object.pro. 2 type %. Literal. Property definition list. Property definition list. Let judge be ordinary object crib. %object.pro. 2 type %. Perform. Property value of property definition list with argument judge. Return judge. Letter L property name. Identifier name. Return string value of identifier name. Letter L property name. String letter L first. Return the SV of string letter L. Letter L property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return toString, NBR. Computed property name. Assignment expression. Let exvalue be. Evaluation of assignment expression. Let prop name be. Get value. Exvalue. Return top property key. Prop name 3255 runtime semantics, property definition. The syntax directed operation property definition takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: property definition list, property definition list, property definition. The form: property definition of property definition list with argument object. The form: property definition of property definition with argument object. Return unused. ECMA International 2024251. Property definition. Assignment expression. Let exp_value be. Evaluation of assignment expression. Let from_value be. Get value. Exp_value. Let excluded names be a new empty list. The form: copy data properties, object, from value, excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let exp_value be. Evaluation of identifier reference. Let prop value be. Get value. Exp_value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Created at throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON.parse, see step 7 or JSON.parse, then A. Let is proto setter be false, else if prop key is proto and is computed property of property name is false, then A. Let is proto setter be true, else A. Let is proto setter be false. If a synonymous assignment expression is true and is proto setter is false, then A. Let prop value be. Named evaluation of assignment expression with argument prop key, else A. Let exp_value be. Evaluation of assignment expression B. Let prop value be. Get value. Exp_value. If his proto setter is true, then A. If prop value is an object or prop value is null, then I perform object prop value. B. Return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Created at throw. Object. Prop key. Prop value 0. Return unused. Property definition. Method definition. The form: method definition of method definition with arguments object and true. Return unused. 326 Function defining expressions. C15.2 for primary expression, function expression. C15.5 for primary expression, generator expression. C15.7 for primary expression, class expression. C15.8 for primary expression, async function. C15.6 for primary expression, async and narrator expression. 52. Copyright sign, ECMA International 2024. 13.2.7 Irregular expression literal syntax. C12.9.5. 3.2.7.1 Static semantics, early errors. Primary expression, regulator x. It is a syntax error if is valid regular x, regulator x, is false. 3.2.7.2 Static semantics, is valid regular x, literal. The abstract operation is valid regular x takes argument literal, a regulator x parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be bodied text of literal. If U is false and V is false, then A let string value be code point store string, pattern text, B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements or string value as a Unicode BMP code point. UTF 16 decoding is not applied to the elements. Let parser result be parse pattern, pattern text, U, V. If parser result is a parse node, return true, else return false. 3273 Runtime semantics, evaluation primary expression, regulator x. Let pattern be code point store string, bodied text of regulator x. Let flags be code point store string, flag text of regulator x. Return. regex create, pattern, flags. 328 template literal syntax. Template literal, yield, await, tag. No substitution template. Substitute item, yield, await, tag. Substitute item, yield, await, tag. Template head expression, plus in, yield, await. Template spans, yield, await, tag. Template spans, yield, await, tag. Template tail, template middleist, yield, await, tag. Template tail, ECMA International 2024253. Template middleist, yield, await, tag. Template middle expression, plus in, yield, await. Template middleist, yield, await, tag. Template middle expression, plus in, yield, await. 3281 static semantics, early errors. Template literal, yield, await, tag. No substitution template. It is a syntax error if the tag parameter was not set and no substitution template contains note escape sequence. Template literal, yield, await, tag. Substitute item, yield, await, tag. It is a syntax error if the number of elements in the result of template strings of template literal with argument false is greater than or equal to 232. Substitute item, yield, await, tag. Template head expression, plus in, yield, await. Template spans, yield, await, tag. It is a syntax error if the tag parameter was not set and template head contains note escape sequence. Template spans, yield, await, tag. Template tail, it is a syntax error if the tag parameter was not set and template tail contains note escape sequence. Template middleist, yield, await, tag. Template middle expression, plus in, yield, await. Template middleist, yield, await, tag. Template middle expression, plus in, yield, await. It is a syntax error if the tag parameter was not set and template middle contains note escape sequence. 3282 static semantics, template strings. The syntax directed operation template strings takes argument raw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return, template string, no substitution template. Raw. Substitute item, template head expression template spans. Let head be, template string, template head, raw. Let tail be template strings of template spans with argument raw. Return the list concatenation of head and tail. Template spans, template tail. Return, template string, template tail, raw. Template spans, template middleist template tail. Let middle be template strings of template middleist with argument raw. Let tail be template string, template tail, raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middleist, template middle expression 1. Return, template string, template middle, raw. Template middleist, template middleist template middle expression. Let front be template strings of template middleist with argument raw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3283 static semantics, template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token. Return string 3284 GLI template TRG, template literal. The abstract operation GLI template TRG takes argument template literal, parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element E of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cooked strings be template strings of template literal with argument false. Let count be the number of elements in the list cooked strings. Assert count lesser or equal to 232, 1. Let template be array create count 0. Let reward be array create count 1. Let index be 0, 2. Repeat while index less than count. Let prep be toString, index b let cooked value be cooked strings, index c perform, define property throw, template, prop, property descriptor, cooked value writable, false, true, false, d let value be the string value or strings, index e perform, define property throw, row prop, property descriptor, raw value false, true, false, f set index to index +1 3, perform, set at grid level, row frozen 4, perform, define property throw, template, raw, property descriptor, row false, enumerable, false, false 5, perform, set at grid level, template, frozen 6, append the record, template literal, template, to realm, 7, return template. Note this operation returns undefined if raw is false and template token contains a note escape sequence. In all other cases, it returns a string. ECMA International 2024255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 13286. The template objects are frozen and the same template object is used each time a specific tagged template is evaluated.
Alright, got a stopwatch. I don't know. I'm gonna run it and check, see if it builds. And then if in the sleep function or whatever, you should sleep for 2,000 milliseconds. That's water. You should sleep for 2,000 milliseconds. And I'll check the printf here at the end and see if it's close to this, assuming that it even does sleep for 2,000 milliseconds. I don't know. I'm gonna run it, or I'm gonna build it, wait a minute and however long for it to freaking build, and then I'll run it and then see if this works and stuff.
Of proceeding and next 3286 runtime semantics evaluation template literal no substitution template. Return a TV of no substitution template as defined in 1296. Substitute item, template head expression template spans. Let head be the TV of template head as defined in 1296. Let subref be evaluation of expression. Let sub be get value. Subref, let middle be toString, sub. Let tail be evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3 future editions of this specification may define additional non-enumerable properties of template objects. Note 1 The string conversion semantics applied to the expression value are like string.pro, to type.concat rather than the plus operator. Template spans, template tail. Return the TV of template tail as defined in 1296. Template spans, template middle list template tail. Let head be evaluation of template middle list. Let tail be the TV of template tail as defined in 1296. Return the string concatenation of head and tail. Template middle list, template middle expression. Let head be the TV of template middle as defined in 1296. Let subref be evaluation of expression. Let sub be get value. Subref, let middle be toString, sub. Return the string concatenation of head and middle. Template middle list, template middle list, template middle expression. Let rest be evaluation of template middle list. Let middle be the TV of template middle as defined in 1296. Let subref be evaluation of expression. Let sub be get value. Subref, let last be toString, sub. Return the string concatenation of rest, middle, and last. 329 The grouping operator. 3291 Static semantics, early errors. Primary expression, cover-parentheses list. Cover-parentheses list must cover a parenthesized expression. 3292 Runtime semantics, evaluation. Primary expression.
That's just great. So, I gotta do whatever to get the last thing working.
Parenthesized expression. Expression, return, evaluation of expression. This may be of type reference. NOTE to the string conversion semantics applied to the expression value are like string.pro, to type.concat rather than the plus operator. NOTE 3 the string conversion semantics applied to the expression value are like string.pro, to type.concat rather than the plus operator. Note this algorithm does not apply getValue to evaluation of expression. The principal motivation for this is so that operators such as delete and type.
I think it's because I disabled C++ extensions.
18.3 left. Member expression, yield, await. Primary expression, yield, await. Member expression, yield, await. Expression, plus in, yield, await. Member expression, yield, await. Identifier name member expression, yield, await. Template literal, yield, await. Plus tagged, super property, yield, await. Meta property. New member expression, yield, await. Arguments, yield, await. Member expression, yield, await. Private identifier, super property, yield, await. Super, expression, plus in, yield, await. Super, identifier name. Meta property, new target. Import meta new target. New target. Import meta. Import meta. New expression, yield, await. Member expression, yield, await. New expression, yield, await. Cal expression, yield, await. Covocal expression in the head, yield, await. Super call, yield, await. Import call, yield, await. Cal expression, yield, await. Arguments, yield, await. Cal expression, yield, await. Expression, plus in, yield, await. Cal expression, yield, await. Identifier name, cal expression, yield, await. Template literal, yield, await. Plus tagged, cal expression, yield, await. Private identifier, super call, yield, await. Super arguments, yield, await. Import call, yield, await. Import, assignment expression, plus in, yield, await. Arguments, yield, await. Incrementalist, yield, await. Incrementalist, yield, await. 58. ECMA International 2024. Incrementalist, yield, await. Assignment expression, plus in, yield, await. Assignment expression, plus in, yield, await. Incrementalist, yield, await. Assignment expression, plus in, yield, await. Incrementalist, yield, await. Assignment expression, plus in, yield, await. Optional expression, yield, await. Member expression, yield, await. Optional chain, yield, await. Cal expression, yield, await. Optional chain, yield, await. Optional expression, yield, await. Optional chain, yield, await. Optional chain, yield, await. Arguments, yield, await. Expression, plus in, yield, await. Identifier name, template literal, yield, await. Plus tagged. Private identifier, optional chain, yield, await. Arguments, yield, await. Optional chain, yield, await. Expression, plus in, yield, await. Optional chain, yield, await. Identifier name, optional chain, yield, await. Template literal, yield, await. Plus tagged, optional chain, yield, await. Private identifier, left the expression, yield, await. New expression, yield, await. Cal expression, yield, await. Optional expression, yield, await. Supplemental syntax. When processing an instance of the production cal expression, covocal expression in the head, the interpretation of covocal expression in the head is refined using the following grammar. Call member x, yield, await. Member expression, yield, await. Arguments, yield, await. 331 static semantics. 3311 static semantics. Early errors. Optional chain. Template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 20242259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A, B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining. A BC, which is a valid statement and where automatic semicolon insertion does not apply. Import meta. Import meta. It is a syntax error if the syntactic goal symbol is not module. 13.3.2 Property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name cal expression, identifier name, or the bracket notation, member expression, expression, cal expression, expression. The dot notation is explained by the following syntactic inversion. Member expression, identifier name, is identical in its behavior to memberexpression less than identifier name string, and similarly cal expression, identifier name, is identical in its behavior to callexpression less than identifier name string, where less than identifier name string is the result of evaluating string value of identifier name. 3321 Runtime semantics, evaluation, member expression, expression. Let base reference be evaluation of member expression. Let base value be get value, base a reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return evaluates with the expressions, base a value, expression, strict. 60. ECMA International 2024. Member expression, identifier name. Let base reference be evaluation of member expression. Let base value be get value, base a reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return evaluate property, base a value, identifier name, strict. Member expression, private identifier. Let base reference be evaluation of member expression. Let base value be get value, base a reference. Let field string be the string of private identifier. Return make private reference, base a value, field string cal expression, expression. Let base reference be evaluation of cal expression. Let base value be get value, base a reference. If the source text matched by this cal expression is strict mode code, let strict be true, else let strict be false. Return evaluates with the expressions, base a value, expression, strict. Cal expression, identifier name. Let base reference be evaluation of cal expression. Let base value be get value, base reference. If the source text matched by this cal expression is strict mode code, let strict be true, else let strict be false. Return evaluate property, base a value, identifier name, strict. Cal expression, private identifier. Let base reference be evaluation of cal expression. Let base value be get value, base a reference. Let field string be the string of private identifier. Return make private reference, base a value, field string. 333 evaluates with the expressions, base a value, expression, strict. The abstract operation evaluates with the expressions takes arguments base a value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be evaluation of expression. Let property name value be getvalue, property name reference. Let property key be top property key, property name value. Return the reference record, base a value, property key, strict this value. Empty. 334 evaluate property, base a value, identifier name, strict. The abstract operation evaluate property takes arguments base a value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name. Return the reference record, base a value. Property name string, strict, empty. ECMA International 2024261 1335 Theno operator 3351 runtime semantics, evaluation, new expression, new expression, return, evaluate new expression, empty, member expression, new member expression arguments 1, return, evaluate new, member expression, arguments, 33511 evaluate new, construct X, arguments. The abstract operation evaluate new takes arguments construct X, a new expression parse node or a member expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let ref be evaluation of construct X. Let constructor be get value. Ref, if arguments is empty, then a let argolist be a new empty list. 4. Else a let argolist be incremental evaluation of arguments. If is constructor is false, throw a type error exception. Return constructor argolist. 336 function calls. 3361 runtime semantics evaluation cal expression covocal expression in the head. Let expra be the call member X that is covered by covocal exp row head. Let member X be the member expression of expra. Let arguments be the arguments of expra. Let ref be evaluation of member X. Let func be get value. Ref, if ref is a reference record, is property reference. Ref is false, and ref is evil, then if some evil u, func, %evil % is true, then I let evaluation of arguments.
I'm including the Windows header. It'll probably break things. Because they define a bunch of shit. And it messes up other stuff. I don't want to turn on C++ because that also messes with stuff. I need no C++. I need no Windows header. So we'll see what happens. I have a timer somewhere that's printing, so I have to find where that one's at and then duplicate it. I don't know which library call it was using. I found one, but it wasn't. It didn't work. Shit.
The abstract operation evaluate call takes arguments func, and ECMAScript language value, ref, and ECMAScript language value, or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then a. If is property reference, ref, is true, then I let this value be getter's value. Ref b else I let ref n be ref. 2. Assert, ref n is an environment record. 3. Let this value be ref n dot with base object, else I let this value.
This is what I typed over.
Incremental evaluation of arguments. If func is not an object, throw a type error exception. If a callable, func, is false, throw a type error exception.
So that's what I typed up, whatever. That's what the compiler says. Missing semicolon before query performance counter.
Let env be get this environment. Let actual this be the env dot get this by
Query performance counter. Oh, it is actually missing a semicolon. Okay.
property.
Looks like it was right for once out of 10 times it's not.
Property is strict mode code. Let strict be true, else let strict be false. Return, make super parity reference, actual this, property key, strict, super property, super, identifier name, let env be
And then wait another minute and 20 fucking seconds.
If the source text matched by this sub.
As the CPU is like barely being used. Only 33-35%.
Strict, super call, super arguments.
But logging to the console or updating this text here, that gets the CPU going 50-60%. But when it does the compiling of the program itself, it's not doing anything. Unless they're lying, it's doing a whole bunch of stuff, and they want to make the stats look lower. Which I could see them doing, because I don't know how it's even compiling without using any memory or disk. Like, this makes no sense. How the fuck is it building this program if the CPU isn't going up usage by a lot and there's no RAM usage? They're fucking hiding the actual like process as it's running. Oh no, maybe it's using such a little fucking memory. Oh, I think it's done. It wrote to the standard out. It's literally a fucking file. This is so out of date. The whole OS, it's a bunch of shit.
Script language value. Property key. A property key.
The whole thing runs off the fucking file system. It's ridiculous.
Reference record, or a throw completion. It performs the following steps when called. Let env be get this environment. Assert env.
And then run.
Let base value be env.get super base. Return the reference record.
I have to turn debugging off. 'Cause it keeps pausing. Say and press enter.
Evaluation of
It'll clearly mess up speed test.
one runtime semantic.
I have to hit enter between operations.
Evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values, or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Incrementalist. Assignment expression. Let ref be. Evaluation of assignment expression.
I think I actually paused.
Ref.
It's not accurate. It's off by a whole second. Oh my god.
Let iterator record me. Jet iterator. Spreadob. Sync.
Windows is shit. Everything is shit. I'm done with this today. I can't take it. It's so fucking annoying.
Argumentalist. Assignment expression. 1. 2. Let presettings be. Incremental evaluation of argumentalist. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of presettings and arg. Argumentalist. Assignment text.
So
Evaluation of argument. of assignment expression. Let iterator record me.
I fixed there. He's missing a semicolon after his sleep function.
Value. Iterator record. B if next is done. Return presettings. See append next to presettings. Template literal. No substitution template. Let template literal be this template literal. Let set the obj be gly template yab. Template literal. Return. Set the obj. Template literal. Substitution item. Let template literal be this template literal. Let set the obj be gly template yab. Template literal. Let remaining be. Incremental evaluation of substitution item. Return the list concatenation or set the obj and remaining substitution item. Template head expression template spans. Let first subref be. EV.
Okay, so I ran this.
Get value. First subref. Let rest sub be. Substitution.
Let's go here. His chatbot said. So I slept, made it sleep for 2 seconds. Which means that the timeout measured the time whatever between should be 2.
B. Evaluation of.
It's fucking 3. Or no, hold on. I don't even know what number that is. What is that? Milliseconds? Microseconds?
Cal expression optional chain. Let base reference be. Evaluation of cal expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. NOT. An optional chain is a chain of one or more property access and function calls, the first of which begins with the token ECMA International 2024265. Optional expression. Optional expression. Optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. 3392 Runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record or an abrupt completion.
It literally gave me the same fucking thing. Fuck's sake.
Chain. Let tail call be is in tail position to chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text matched by this optional chain is strict mode code. If you're logging start.quadpart or end.quadpart directly, you're just seeing the raw tick count, which is not meaningful by itself unless you compute the difference and convert it using the frequency. If you're logging start.quadpart or end.quadpart directly, you're just seeing the raw tick count, which is not meaningful by itself unless you compute the difference and convert it using the frequency. end.quadpart. Start.quadpart. freq.quadpart. Should print approximately 2.0000000.
It's nowhere near close to that. Is chatbot stupid or what? It gave me the same exact thing. It literally says, if you're logging quadpart directly, which is what they say to do, right here. By they I mean chatbot, because chatbot runs off training data that was set up by people. So it's giving the raw tick count, which isn't meaningful, unless you compute the difference and convert it using frequency, which is what chatbot said it did right here. It does divided by frequency. It's the same fucking thing. I'm so annoyed. It doesn't work. Oh my god, is this thing stupid? I literally fucking typed that. I didn't even ask it if that's what... Right here, I have fucking end minus start divided by frequency. Is it because it's casting it to a fucking double? Does that double need to be... Hold on. think it might need to be wrapped like this. So it casts the result, not just, I don't know what it's fucking. I'm just gonna wrap it in parentheses. See if that changes it. I had to wait a minute, 20 fucking seconds.
And it's giving you something like 33,688.682269, then either you're printing something else, e.g., just end.quadpart, freq.quadpart, or freq.quadpart is not being set properly, e.g., you didn't call query performance successfully, or something is overwriting your start or end values.
If this doesn't work, I'm done. I'm so fucking annoyed. The modern operating system is shit. The C++ and C is a fucking joke. For fuck's sake. Like, what the fuck is this?
And it's giving you something like 33,688.682269, then either you're printing something else, e.g., just end.quadpart, freq.quadpart.
Which I'm clearly not. I'm literally printing what Java told me to do. I don't know, I'm gonna run it and see what happens. I don't have the attention span today. It's pissing me off. Fucking sitting here waiting. This frequency thing is stupid as fuck. It doesn't work. Just want the fucking time without C++. It's cool. It's great. Okay, so now, after chatbot's advice, whatever, I even wrap this parentheses to like make sure it didn't cast and then divide, just in case, whatever. So here's the result. So looks like it rounded this time to perfect rounding, 0. So this cast here, I think it made a difference by wrapping it here. So I wrapped it like this, so it cast it after, which means it truncated it, which means that doing it like this caused it to truncate only the first part, but not the second part. So you get the remainder here, which isn't anything close to, I don't know. But when I truncate it after, like this, and now it does whatever. And then the whole thing is truncated as total to a double. Then I get all zeros at the end because they've been clipped. But the higher part, which is still wrong, is still not anywhere close to 2. Or even 3. It's not even the right measurement. Is the timestamp even the fucking time? Stay tuned for the next terrible stream. Fuck Windows. I'm gonna let the stream run on for 10 more minutes. I'm done for now. The stream doesn't always end because this is the modern operating system. And when you send a stream, it doesn't always send because it's so modern and it's the year 2025 and things are complicated, like getting the time and like why the fuck does frequency have anything to do with the time? That's with the processor clock and instruction cycle counting. Of course it's not going to be accurate. Why is chatbot saying it'll be accurate? For fuck's sake. So I'm gonna let the stream run on for 10 more minutes. Peace.
In, yield, await, plus yield, yield expression, in, await, arrow function, in, yield, await, async arrow function, in, yield, await, left parenthesis expression, yield, await, equals assignment expression, in, yield, await, left parenthesis expression, yield, await, assignment operator assignment expression, in, yield, await, left parenthesis expression, yield, await, and an equals assignment expression, in, yield, await, left parenthesis expression, yield, await, equals assignment expression, in, yield, await, left parenthesis expression, yield, await, equals assignment expression, in, yield, await, assignment operator, 1 or equals, percent equals plus equals less than equals, and equals to the power equals, 3151 static semantics, early errors, assignment expression, left parenthesis expression equals assignment expression. If left parenthesis expression is either an object literal or an array literal, the following early error rules are applied. Left parenthesis expression must cover an assignment pattern. If left parenthesis expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assign on target type of left parenthesis expression is not simple assignment expression. left the expression assignment operator assignment expression left the expression and equals assignment expression left the expression equals assignment expression left the expression equals assignment expression. It is a syntax error if assign on target type of left the expression is not simple. 3152 Runtime semantics. Evaluation. Assignment expression, left the expression equals assignment expression. 82. If left the expression is neither an object literal nor an array literal, then a let FP. Evaluation of left the expression. B. If is an anonymous assignment expression and is identifier for left the expression are both true, then I let B. Named evaluation of assignment expression with argument ref. C. Else I let FP. Evaluation of assignment expression. 2. Let B. Get value. Ref D perform. Put value. Ref. Reval. Return reval. Let assignment pattern be the assignment pattern that is covered by left the expression. ECMA International 2024. 3. Let ref be. Evaluation of assignment expression. Let reval be. Get value. Ref. Perform. Destructuring assignment evaluation of assignment pattern with argument reval. Return reval. Assignment expression. Left the expression assignment operator assignment expression. Let ref be. Evaluation of left the expression. Let val be. Get value. Ref. Let ref be. Evaluation of assignment expression. Let reval be. Get value. Ref. Let assignment obst be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment obst in the following table. Assignment obst op text equals percent equals percent plus equals less than equals less than equals and to the power equals. Let R be a plus string enumerate operator. Vol op text reval perform put value. Ref, R, return R. Assignment expression, left the expression and equals assignment expression. Let ref be. Evaluation of left the expression. Let val be. Get value. Ref, let be to boolean. Val. If is false, return val. If a anonymous assignment expression is true and is identifier of left the expression is true, then a let reval be. Named evaluation of assignment expression with argument ref. Else a let ref be. Evaluation of assignment expression by let reval be. Get value. Ref. Perform. Put value. Ref. Reval. Return reval. Assignment expression. Left the expression equals assignment expression. Let ref be. Evaluation of left the expression. Let val be. Get value. Ref. Let be to boolean. Val. If is true. Return val. If a anonymous assignment expression is true and is identifier of left the expression is true, then a let reval be. Named evaluation of assignment expression with argument ref. 6. Else a let ref be. Evaluation of assignment expression by let reval be. Get value. Ref. ECMA International 20242883. 7. Perform. Put value. Ref. Reval. Return reval. Assignment expression. Left the expression equals assignment expression. Let ref be. Evaluation of left the expression. Let val be. Get value. Ref. If val is neither undefined nor null, return val. If a anonymous assignment expression is true and is identifier for left the expression is true, then a let reval be. Named evaluation of assignment expression with argument ref. Else a let ref be. Evaluation of assignment expression by let reval be. Get value. Ref. Perform. Put value. Ref. Reval. Return reval. 3153 a plus string enumerate operator. Val op text reval. The abstract operation a plus string enumerate operator takes arguments val and ECMAScript language value. Op text percent plus less than and to the power or and reval an ECMAScript language value, and returns either a normal completion containing either a string, a digit, or a number, or a throw completion. It performs the following steps when called. If op text is plus, then a let be, top primitive, val by let be, top primitive, reval. See if lapom is a string or rum is a string, then I letter L at RB, toString, LPOM 2. Letter R erased B, toString, rum 3. Return the string concatenation of L at R and RSTR. Deset lval to LPOM. Eset reval to rum, NOT. At this point, it must be a numeric operation. Let lum be, to numeric, lval, let runum be, to numeric, reval. If type, lum, is not type, runum, throw a type error exception. If lum is abigent, then n. Note when this expression occurs within strict mode code, it is a runtime error if lref in step 1d, 2 is a non-resolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the lref in step 8, 7, 6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value undefined, or to a non-existent property of an object for which the extensible predicate returns the value false. In these cases, a type error exception is thrown.